Hello, I'm MC Toon, the worst rapper in the world. Tonight, I've got a debate, a flat earth debate, with an Australian who thinks the earth is flat, named Tony Naoum. How are you doing, Tony?
Good, Mike, and you?
I am great. It's been
Excellent.
great here. Now, normally I have a debate on Tuesdays. This week it worked out to have it tonight, and I know that FDFE is just wrapping up his debate right now, and I know that a few people will probably pop over from there. So I expect we'll see.
We can hold off and do some small talk while you're waiting.
Sure. And before we get into the meat, so
how about I just address the elephant in the room while we're waiting, right?
Where's the elephant?
There's an elephant in the room, and you've already mentioned it, that I'm from Australia. And Australia does exist. So can we have sphere earthers stop quoting flat earthers as saying it doesn't exist? I'm just going outside. So if I drop the computer now, the debate is over, okay? If we look that way, can you see the Sydney skyline? Are you able to see that Sydney skyline? Or is it too far away?
Maybe a little. I don't know.
So that's Sydney. That's Sydney, and I'm in Australia. So, guys, it does exist. I just want to make sure that we have that settled from the beginning.
So, do you have like anti-gravity shoes on then to hold yourself down?
let's get to gravity. Let's get to gravity. Let's start with flat Earth, but if the time permits, we'll get to gravity. I'll also while we're waiting, just let you know there's no one here Googling information for me or Googling references.
So you don't have any coach, so Kiwi will be happy.
No.
Very good.
There is, however, a wild savannah cat, which may at any time may decide to attack me. Okay, Mike? So if that happens, and I'm in a bit of pain, you'll know why. Okay. Other than that, I'm on my own.
All right. So what was the the elephant was that you're in Australia.
Yeah. Just to let you know, the background on that, while we'll kill some time, is this. Once upon a time, the known world believed that there was a huge southern continent called Terra Australis. They believed that existed to balance out the world. So it was hypothesized that there was this huge land. Then a gentleman called Van Diemen, he sailed to the southern hemisphere. We'll call it a hemisphere because that's what language you guys want to discuss, southern hemisphere. And then Captain Cook also traveled south of the equator, and he then proved that there was no such landmass. So true, there's no such thing as a landmass called Terra Australis, but there is such thing as a country called Australia. So that's where the confusion comes from, I think. So I'm glad we put that one aside.
Okay. Now, somebody in the chat already said this.
Yes.
And I don't like it. Said, why is the moon in Australia upside down? And I'll tell you why. After you say it, I'll tell you why I don't like it.
Why don't you like it? I think it's a very valid question.
I think it's for the globe versus flat. I think it doesn't change anything. Yeah.
Yeah, I agree with you. That we totally agree with. Yeah, it makes no difference what shape of the Earth you believe in. If you imagine the moon is predominantly on the equator, traveling around the equator, whether it's us traveling around us in your belief, or it traveling around the flat Earth, if it's on the equator, we're going to see it from different perspectives. It's that simple. Yeah. So
I've heard people explain it, and this totally works. If you put a 6 on the ceiling. And stand on one side of the ceiling, flat floor, walk to the other side, you see a 9. So the moon upside down in Australia versus America doesn't mean anything.
You would be amazed how people from both sides of the argument will argue tooth and nail about that common belief.
Yeah.
There are certain aspects, regardless of what shape of the Earth you believe it is, that are going to be common to both. So, and that's one of them.
Yeah,
that's one of them. However, where we don't agree, since we're just killing some time, is whether the moon emits its own light or not.
Ooh.
That's a big discussion, which could be a topic for another debate.
Yeah, and that's an inconsistent claim by different flat earthers. Some say it emits its own light, and some don't.
Okay, and you know what? It's a common problem amongst flat earthers. Let's look at it this way. NASA is a source of information for you guys, right? It's a central source. What they say tends to be the belief, right? Flat Earth has no such authority. So you'll have one sort of thought leader saying doesn't mean, one thought leader saying it doesn't, one saying it's made of plasma, the other saying it's a rock. So we don't have that central body that gives us a certain belief. You have to do your own research. You have to do your own research, and you have to dig. And that's what I did for a long period of time in my spare time to get to where I got to. That's an entirely different debate on its own. You know, these are all little offshoots for debates that can be had, you know, and ones that would take a fair bit of time. So let's not occupy it with that. We can always get to that. Michael, you're in charge here. This is your channel. So you can lead it. We have a format, but you can lead this wherever you like.
We do. All right. I will, excuse me. I will pull up the format.
Sure.
Oh, let's see what was. Well, it's on my website, mctoon.net, and then if you search for format, everybody, I'll give you the link in a second here, and I'll put it up on screen. It's the 4-topic format. So each of us will have 2 topics that we present, but one at a time, right? So the structure is one person presents for 5 minutes, and the other is quiet, and then the other has a response for 5 minutes, and exchanging who's quiet, and then we have a 10-minute open discussion. So the link is in the chat for people who want to have a look at the format that we're doing. But I'll put a timer on my phone.
Yeah.
And we don't have to be super strict. It's just. But
if I get long-winded, definitely cut me off.
Yeah,
because I get a little bit excited about this topic. So
you'll hear the alarm on my phone. It's kind of a tingling bell or something.
That sounds good. That's a good idea. That's a good idea.
So,
all right. And please, while you're talking, if I'm silent and I'm jotting things down, don't think I'm not paying attention or being disrespectful. I'll just be taking notes so I don't interrupt you as you're talking.
Yeah.
Okay.
All right. So we've got a question. If you don't mind answering this or addressing it,
sure.
From the audience, we've got somebody who has the catchy name. I've never seen such behavior in the war room before. Says in Australia, you can see the stars that are directly over South America by looking south. How?
Sorry, say that again.
So I think he's referring to the AE map.
Yes.
He says in Australia, you can see the stars that are directly over South America by looking south.
Okay, depends on what part of Australia you're from. If you're in Perth and it's daylight already, and it's in Sydney, it's still nighttime, and South America's in night, of course you're going to see the same stars. Let me try to explain something. And for those of you who are old enough to remember I Dream of Jeannie, I'm going to look like the genie in a moment. Okay, so if I hold my hands up, say that's the Earth's surface, right? And the bottom of my hand is you. You're standing here, and the tip of my fingers is Polaris. Let's talk about Polaris, the Northern Star, right? Yeah. Now, you're standing directly on the northern pole. Let's call it the pole, right? You start to move away from the pole, right? This is what happens. Polaris starts to drop in the sky. It's actually getting lower.
Yeah.
It's a matter of perspective, right? Until you reach the equator, it's no longer visible. That's why Polaris is not visible from the south of the equator. And the same is true for stars south of the equator. Okay, well, I want to discuss that when we talk about the tilt. So I'll get into crux, and we'll talk about the Southern Star and exactly what this woman is asking about in greater detail. But yeah, you can absolutely see the stars in the Southern Hemisphere. I can't see Polaris though. I can't see things beyond 90 degrees. So if Sydney is minus 32 degrees south, anything beyond 60 degrees north, I can't see those stars. It's a matter of perspective. Remember, that's exactly what happens when you move away from something. And whether it's a traffic light or a lamp on the street, stand under it and then start moving away. It starts to disappear, which is also how the sun appears to set, which we can talk about a little bit later. But yeah, I'd love to discuss the stars if we have time, and I will later on.
Right. Well, let's. I'm hearing feedback from myself through your system. Let's do this. Let's do.
What can I do about that?
Well, if you don't have earbuds to use, then there's nothing.
I can get earbuds. Do you want to give me 2 minutes? I'll get my earbuds.
Sure.
Okay. Give me 1 second.
All right. Mute donkey. Yeah, you're correct. And let's see, Professor Phil Bell, I got your email about Gary Wybenga. He has not sent me any message saying that he would like to debate you. So Not surprising. He is a little scared sometimes. He likes to talk, but not back anything up. So maybe someday he'll find that courage. So,
Michael, can you give me 2 seconds to connect it to, because I've never connected them to my laptop before.
Sure.
Just give me 2 seconds and I'll take them off.
In the meantime, I'll debate your cat.
My what? Sorry.
Your cat. I'm going to debate your cat while you do that.
He's absolutely crazy.
Kang042, yes, in fact, he did say that. But well, maybe we'll address that later. We're doing a little prep, or a little time buffering here, not buffering, whatever. Waiting a little bit because FTFE is almost done, but we don't need to.
That's okay. That's fine. I'm just setting up. I'm just setting up the Bluetooth now as we speak.
Yep.
For the earbuds.
As long as it's not a 5G directed energy weapon in the form of the Ark of the Covenant. Yeah. There. If you didn't see it, people, Mark Steele thinks that the Ark of the Covenant was 5G. Really,
oh wow!
He said that. QED, can I shill the link? What link do you want to shill, QED? Here we go. QED, shill away. So yeah, it is amazing, and I'm working on another. I've got 13 more short videos about Mark Steele and the things that he says that are just insane. He had a court case yesterday that was dismissed, and he had crowdfunded £30,000 to pay for this court case. And I'm sure that he's figuring a way to bill out all that £30,000. I don't know if he is or not, but would not be surprised. Yeah.
Michael, I'm just working this out. Won't be long.
Yeah, it's okay. It is basically, I think he saw Indiana Jones and thought it was a documentary. And seriously, oh, poor guy. So, well, anybody have any questions for me? While he's trying to get his audio going a little bit more.
So many things paired to this thing. It's just trying to find a.
Yep. PhD Tony. Yeah. Seismic data. Yeah. That would be. Why don't they crowdfund a trip to Antarctica? That'd be fun. My guess is just like when Ranty Flat Earth said, I'm not a flat earther anymore, they would treat anybody that went to Antarctica and said, oops, that I was wrong, Antarctica is this. They would say, oh, that guy was never real, he's totally a shill.
Michael, I'm really sorry. I'm just trying to work out how to do these.
Yeah.
iPod things. I can't. I'm IT illiterate, honestly. I can connect them to my phone. I just don't seem to be able to do it. It's not being picked up.
That's okay. It's not a lot of.
Is it okay? Is it manageable?
Yeah, it's manageable.
Okay. All right. Cool. All right. Okay. Where were we? Are we ready to go? Or
we're ready to go. So, do you want to start or should I start?
You can start. I've still got some intro stuff to do. Just a little bit about my background, a little bit about myself. That's before the debate. I think your viewers deserve to know a little bit about me and maybe a little bit about our experience and how we met. And then we can start the debate. Maybe buy a bit more time as well.
Yeah, let's do that then. That's fine.
Yep. Would you like me to just give you a little bit of my background for your viewers?
Yeah, go ahead.
Okay, great. All right, cool. All right, so I'll start with a little bit about our experience, Michael. Once I'd done the research. Okay, what about I start with why flat Earth? Why did I become a flat earther? Okay, so I've got 3 degrees. My first degree is a medical degree. First 2 years of that degree are basically physics and chemistry. It's all science-based, and I was a staunch sphere earther, staunch believer in gravity, staunch about all the beliefs. Until one day I had a gentleman mention flat Earth, and I laughed and carried on, ridiculed as we all do when we believe in the sphere Earth. Then he's challenged me. He gave me 24 hours and said, "Prove there's a curve beyond the horizon." And I said, "That's a cinch. I'll get back to you in a couple of hours. It won't even take 24. So I went through the research. I went through observations. I went through all that information, looked at the sphere geometry, and I couldn't do it. Truth is, I couldn't do it. And that made me stand up and think about it a little bit more, and then began a 6-month research. You spoke to me at midnight the other night. I'm an insomniac. So I finished my law work, and then I'll spend 2 or 3 hours doing research. So I did that for 6 months and couldn't believe what I uncovered. The details we can talk about a little bit later. So that's what got me started on the flat earth. So even with all this educational background, university level, high school level physics and chemistry, it all kind of fell in a heap when I started doing the research. Then I joined Facebook and joined some groups and met some very interesting people. There were times when it was really informative. There were times when I'd get death threats for my beliefs. So it's quite interesting. We met Michael because we you got involved in a debate I was having, and you came across that arrogant at the start, but I like that about you. I like that about you. And we started to have some discussions, and some of them were very amicable, some became quite heated, but it was always respectful. And you made contact with me and said, look, why don't we have a debate online? And it was just never suitable because of the time frame. We had the middle of the day here, I'd be at work while you guys were in your evening. So it just wasn't possible. And now in Sydney, which you probably all heard on the news, we're in basically lockdown. I'm in house arrest, just without the ankle bracelet. So it's an opportune time for us to talk. So that's a little bit about the background that we had. But I want to talk about one particular guy, about my experiences on Facebook. I won't mention his name, Michael, because you probably know him. He's part of the group. This guy got so riled up that he sent me an inbox saying, F you, F this, F that, I want to beat you up. And, and I just stirred him on. I said, mate, look, I'm a prize fighter. You're not going to get very far. I've got a black belt in Taekwondo. You're not going to get very far if you want to fight me. But I said, okay, fine. Let's meet at the pub on Saturday at 4 p.m. Right? He goes, fine, which one? I said, the one near your place. He goes, wonderful. Okay, I'll be there. So I get a message on Facebook, on Messenger on the Monday. He goes, where were you, you coward? You didn't show up. He goes, look, I'm sorry, I got held up. My bad. How about we do it at the park near your place on this Saturday at 4 p.m. He goes, yeah, you better show up. I said, look, you better come ready. You better come armed, because I'm not an easy one. I'm not an easy guy to beat. He goes, fine. So anyway, he messages me again.
Better come armed.
He messaged me again. He goes, you coward, you didn't show up. I said, listen, you're such a dope. You're in London and I'm in Sydney. So the whole time he was expecting me to show up at the pub near his house or the park near his house. I was not even in the same country, let alone the same continent. But these are the sort of guys I get. I mean, why can't we, like you and I, have amicable discussions about sphere Earth, flat Earth, and just walk away and say, look, we agree to disagree. We have our heated moments, but it's okay. So Facebook's been really interesting for me. It's been quite an experience. And some other people may know me under the profile of Saphira. Someone stole my identity, which I found out about, and changed the password and kept that account. So whenever one of the snowflakes from Sphere Earth would report me and lock down my profile, I just jump on Saphira. So you might know me from either one of those profiles. That's a little bit of the Facebook background and my history with you. But I've always had respect for you, Michael. You know that.
Yes, it's been pretty good mostly. And you're right. Sometimes it did get heated, and I think there's plenty of blame to go around.
That's fine. And I'm willing to share some of that as well. Okay, so a little bit about my background. First degree, as I said, was medical. I wrote a thesis on cranial nerve damage in motor vehicle accidents. So science, I love science. I've written papers on science, and I know what the scientific method is all about. So when people are talking about copy and pasting and references, so well, no, most of this stuff's committed to memory. If I make a claim, this is the lawyer side of me. If I make a claim, it'll be 100% backed up. I don't make opinionated claims. My opinion means nothing. It's worth nothing. So if I make a claim about something, please notify your viewers. Please notify Michael and ask for that reference. And if I get a list of all the references that have been asked for, I'll send them in one hit to Michael and he can post them. So, and all those references are either observations or studies that adhere to the scientific method. So can I please put that up front? No one's here helping me. I'm not copy and pasting anything. We can talk about flat Earth, gravity, Big Bang, evolution, whatever you like, and it's all committed to memory, and all the studies are committed to memory. So I can talk about those freely anytime you like. So that's a little bit about my background. The final thing is, support this channel, all your viewers, buy stuff, contribute. again, Michael does this for a bit of love, but he also does this because it's a business. So keep doing this. And if we break some records on some revenue, Michael, I'll come back again and they can hate on me twice, right? So I'm happy to do a series of debates with you if your viewers enjoy it, but so long as they make you some money as well, okay? So that's a little bit about that's the preface. That's the stuff that I'd like to talk about. We can get into it if you like. And you can start, please.
Awesome. Okay, well, I will have I'll do a 5 minutes, and let me get my. And what I'll do is I'll present my screen so you can see it, and so the crowd can see it. Oh, I need to make sure that's set up here. Just a second.
Yeah. So you're computer literate. You understand what you're doing. So I can't do any of that. I don't understand how to put up references or whatever online while we're talking. So that's my problem. But as I said, any references your viewers would like afterwards, happy to supply them.
All right. Well, good. So I have I will start this here. People can see that now, but I need to send that so you can see it. So I'm going to test two hypotheses.
Sure.
One for the Earth being flat and one for the Earth being spherical. Now I am using the AE map, which may or may not be the map that you like. And so if this is a map that you don't like, then we could maybe test
that's fine. I understand the point you're trying to make. Yep.
Yeah. So on the AE map from southern Australia, not far from you, which is 30 degrees south and 150 degrees east. Mm-hmm. I chose that just because it's good round numbers. Mm-hmm. So the flat Earth AE map prediction for sunrise and sunset on December 21st. It's the same every year.
Close to the summer solstice, yeah.
Yeah.
Close to our summer solstice, yep.
Yeah. Well, some days it's the 20th, some it's the 21st, right?
Yeah, 22nd even. Moves around a bit, yep.
Yeah. So the prediction is, because the sun is up for 14 hours, it's from when the first bit of the sun is visible until the last bit of the sun is obstructed by the horizon. So if you're near the water, you'd see this, but if there's a little bit of land, it can vary a bit. But it would be 53 degrees north of due east is the prediction for flat Earth for the AE map. For the sunrise and sunsets, the mirror image of that is 53 degrees north of due west is the predicted time that the sun would set.
North of due west. Okay.
Angle, not time.
Yeah, no, I'm with you. Yep.
Then for the globe, I used an actual physical globe, and this is sitting on my kitchen table. You can see on the top there, the light over on the right, the globe over on the left. The light is off. Then on the bottom, I had turned the light on so you can see the angle of the sun coming in. You can see also that it is set up. I set it up so that it's tipped towards the correct direction for the December solstice.
Mm-hmm. Yep, I understand that.
And I put that little piece of clay there on that point. So it's a little bit, the margin of error is a little bit bigger than 1 degree probably, because I can't perfectly put that little, there's actually a twist tie that I straightened and a little piece of Play-Doh. And then I pointed it straight so that there was no shadows directly towards the light. And then I measured the angle there, 27.5 degrees. So the prediction for the globe is 27.5 degrees south of due east for sunrise. And then sunset is the mirror image of that. Right?
Okay. Yep.
So now, then I went to suncalc.net and got the actual angle of sunset.
Yep.
And sunrise. 28 degrees south of due east and 28 degrees south of due west. I was 27.5 was my measured one, and the observed is 28 degrees. Very close. But the flat Earth AE map prediction is significantly off. It's nearly 90 degrees off of the actual prediction. So if we took the two hypotheses, one that the Earth is flat with the AE map, the prediction is 53 degrees north of due east. Observation is 28 degrees south of due east. The hypothesis is falsified. And the globe prediction was 27.5 degrees using my rather sloppy margin of error. and the observation is 28 degrees. It's a half a degree off, which is within the margin of error of that type of measurement. My margin of error would probably be 2 or 3 degrees if I were to get specific on it. So that confirms the prediction of the globe. And there you go. 2 hypotheses, 1 confirmed, 1 falsified.
Thank you for sharing that.
That's it.
Okay, so your premise comes from the place that your source is correct, your source is legitimate, and the idea that that's what the sun does is actually a fact. That would be true, right? That would be very true. Yes.
Yeah.
You have to believe that you have to believe that those references, those sources are fact.
Which sources?
The source that you just presented to me.
The angle that the sun is viewed.
Yeah. Right.
Yeah, and being where you are, you could easily confirm that.
Yeah, right. So I am going to confirm that. Let me show you how it's not correct. Okay. I was going for a walk, and it was a beautiful sunset about 3 weeks ago. So actually, just before the winter solstice. So the sun was the furthest away it is from Australia at the time, and I was walking home. And I put up this compass. I don't know if you're going to be able to see this. I'm holding it due north. I put up this compass and I faced it towards the sun. And the sun, if you see that white line, if you hold it north, you see the white line, the thick white line on the left-hand side?
Yeah.
It's north of west, isn't it? It's about 50 degrees. Actually, it's about 30 degrees. No, it's about 50 degrees, 53 degrees north of the west, right? The sun never, ever goes south of Sydney. Never goes south of those coordinates.
When
Why?
was
Because this was about 3 weeks ago. Maybe 4 weeks. It was around the winter solstice. And I'm happy to go outside now and point it towards the sun and show you the sun is always north. In midday, nighttime, anytime, it's always north. Always north of that coordinate.
Okay.
There's no need to go to a reference. I can show you an observation. I can walk outside, send this compass towards the sun and show you the sun never, ever goes south of Sydney, ever. It's always north. And that's the most it goes north because it's the winter solstice. The sun is the most furthest away. That angle will be far less in December. So the sun never, ever goes south of Sydney, ever. In fact, the Tropic of Capricorn is around Rockhampton, which for people who don't know Australia is in North Queensland. The southernmost point the sun ever gets is along Rockhampton. That's where you make beautiful sunsets because the sun is directly above. The sun never, ever goes south of Sydney. Doesn't matter how many references you show me or what sources you go to, I can walk out, and I'm happy to do that tonight. I'm happy to point it directly at sunset and show you it sets northwest. And tomorrow morning, I'm happy to point it at the sunrise and show you it's northeast. Very happy to do that. No sources needed, just a compass is all you need. Compass is all you need. And if we contacted someone in Cairns, which is north of the Tropic of Capricorn, and said, during the summer solstice, show us, do the same thing, and they will show you the sun comes up from the south because it's behind them. It's south of them. There's no need for references. There's no need for sights. I can show you an observation, which is as simple as using a compass. And incidentally, as I was taking this, a gentleman was having a coffee on the sidewalk, and he said, "What are you up to?" And I told him, we started talking about flat Earth. And he was an atheist and he was a staunch sphere earther. We had a fantastic discussion for about half an hour, took hands and walked away. So it was a good discussion to have. And it just came from me standing there, taking a beautiful angle of this beautiful sunset. But you don't need references. I'm happy to show you observations. If you would like, by the time we just have our next debate, very, very happy to take those photos at the start of the day and put a date stamp, and at the end of the day and put a date stamp and show you that the sun never, ever rises or sets south of that coordinate that you sent me.
All right, is that it?
Well, that's my response to your hypothesis.
Okay. So, what month is it?
Now we're in August.
Okay. Mine was December. So you are,
yes.
So right now we are on the other side of the solstice from when I did that.
Correct.
So here's the deal.
Yes.
Suncalc.net, timeanddate.com.
Yep.
I've never seen a flat earther dispute the data that they put out. So you are disputing that.
I absolutely questioned everything before I became a flat earther. Yeah.
So maybe we should table it and come back and you do the observation on
Absolutely.
December 20th.
Happy to, yeah, and we can definitely set up a debate after that. I'll tell you what's going to happen. I will tell you right now the prediction. If you have a look at this and you see the thick white line, you know what the difference is? That angle is going to be less. It's going to be less due north. That's all. You heard me say it now. You can quote me on it on the 20th of December. You'll get the exact same response, except the angle between north and west is going to be larger.
Yeah,
so it's going to be closer to the
at
west.
sunrise and sunset.
100%.
Okay, all right.
100%. Happy to come back to that hypothesis on those dates.
All right. I will. Maybe the rest of this particular topic should be picked up again then, and not spend 10 minutes on it right now.
On this, absolutely, we can move on. Yeah, sure. Okay. I'll make a note of that. Sunrise and sunset. I'll put it in my diary two days before and a day before, and make sure that I do that. Absolutely.
All right.
And I'll even get to the seashore. I'll get to the uninterrupted view of the sun for that. That's no problem.
Yeah, for the sunrise, it'll be hard to get to the seashore for you to see sunset.
It'll be.
You got to get to Perth, or
correct.
Or
sunrise, we're okay.
Or maybe Tasmania. Have you been to Tasmania?
Well, you have a friend there, don't you, Ross Thatcher?
Oh, he's in Tasmania.
Yeah, and I think you've blocked him. He wanted to watch the debate and comment, but I think you blocked him.
I don't like him.
I know you don't like him. We had a chat beforehand.
Don't like him at all.
Ross, I said, Ross, I hope you're going to be on today. He goes, Michael can't stand my guts, so I don't know if I can't make any comments, but I can definitely watch it. So he's watching. If you want to do a shout out,
there are 3 people.
Yes.
3 people in this community that I have no time for. He's one of them.
Yes. Okay. Understandable.
Yeah. And if anybody wonders why, you can look at it.
Yeah.
All of the stuff on mctoon.net/FEAJ, Flat Earth Aussie Jesus, FEAJ.
Okay.
I have screenshots of all of the things that I have problems with.
Yeah. Okay. But I will say one thing. If you actually pick up a phone and talk to him, you'll get along with him. He's a really nice bloke. Nice bloke.
I have spoken with him.
He may come across abrasive, but he's very passionate. But anyway, we're not here to talk about Ross. I just wanted to let you know that he's in Tasmania, so I thought maybe that's why you brought up Tasmania. But
it's because you could see the ocean on both sides if you're in Tasmania. That's all.
Mm-hmm.
I thought he was closer to Sydney. But okay.
You know what? He might be. Or I might have it wrong. So I apologise, Ross, if I have it wrong. I was under the impression that you were in Tasmania. But anyway, regardless.
I work with a guy from Tanzania.
Right.
And every once in a while I mess with him and I say Tasmania on purpose just to give him a little crap. So
it's a slight distance from us.
All right. So we've got while I was talking, I got a couple super chats, if you don't mind. We've got a Kang024 says, for $5 New Zealand dollars, says, Tony, during your research, did you not watch a sunset?
What does that mean? We just spoke about the sunset for 10 minutes. What does that mean?
I think what
this is. This is a sunset.
Yes. Yeah. Well, I think that was before we talked about that.
Okay. Okay.
And he's in New Zealand, so maybe he wants to do a.
He can do the same thing for us. Yeah.
Yeah, he can.
He'll find that his sunrise and his sunset have a greater angle due north.
So I have there's somebody from far South America that contacted me.
Yeah.
And I know somebody in South Africa, so maybe we could get all 3 on December 20th.
That would be absolutely brilliant. That would be brilliant because in the courtroom, if three things happen and there's a single element, it's no longer a coincidence, right? So let's get 3 points. Let's get 3 points across the world: South America, South Africa, and Sydney, and let's all do the same thing.
Maybe throw Perth.
Let's all use the same. And this is the problem with some of the stuff I've seen online. They have these perspective studies around the world. Some sphere earthers have had this, and they're using different forms of methods to measure. You can't do that. So if we're going to do it properly and you want to coordinate it, let's just use the compass that's on the iPhone, and we all have the same methodology. We all get a consistent response. How's that?
There you go.
You might be published because of this, Michael. You could be a published scientist for this study.
These types of things have probably already been done. But okay, FDFE says for £2 this FDFE raid. And he has sent me a message asking if you'd come on his show.
It depends on how much he likes me, and really, I'm Michael's contact. So if Michael is done with me, I'm happy to go on another debate. But if I enjoy you, Michael, I enjoy talking to you. I think you're an absolute gentleman. If we have a series of debates, then I will stick with you. But if you want to release me and you put that in writing, then you can release me out to the other channel. We can go from there. I'm happy to do that.
Don't know if we need it in writing.
So long as they have a good format like you and they're consistent and they're not absolute morons, I'm happy to go on this show.
Well, he can be a bit brusque.
I can be too. I'll just give back what I get. If he's a gentleman to me, right, I'm a gentleman back. If he wants to be an arrogant prick to me, I'll be one back to him. Okay,
so here's the question then that a couple people have asked.
Yes.
If in December,
yes,
you look at the sunrise and the sunset angles and you find that they're south of due east,
yes,
what then?
Then I'll go back to being a sphere earther. How's that?
All right.
How's that?
That sounds good.
And
it's on video.
Lightly. I don't say that lightly because I've done all this stuff before. But believe me, when you've had what I've had fed down my throat at a high school level, university level, I was one of the staunchest sphere earthers you'll ever meet. So for me to change my mind, I did not leave a rock unturned. Everything and one bit of research led to a whole bunch of others, led to a moon landing, led to this, led to that, and it just spiraled out of control. But I explored every single avenue. So there is no topic that we can't discuss that I wouldn't know, and I have the references in my mind. Okay. There's no copy and pasting; it's there. So yeah, absolutely. I'm happy to be challenged on that because I already know the data. I already know the information. I've already seen. I've already tested it. I'm happy to do it again on the summer solstice.
Awesome.
And you heard me. The only difference between that compass reading and the summer solstice is the angle between west and north is going to be smaller. So the sun's closer to us. It's now in Rockhampton. It's no longer over the north of the equator, right?
All right.
That's the only difference.
Okay. It's your turn to do a so if you want, you can share your screen or you can just talk. I'll put your full screen.
As I said to you, I couldn't even connect the iPhone, the iPods. You think I'm going to share a screen right now? I'll lose you.
All right.
Okay, so what I'm going to do is this is the one thing that I'm going to read. One thing in this discussion that I'm going to read. And I want us to have a common understanding and find some common ground on the definition of science. Okay, so your viewers can Google this. They can get whatever definition they like, but you will get this common theme. And let me just read what the most basic definition of science is off a Google search. It's the intellectual and practical activity encompassing the systematic study of the structure and behavior of the physical and natural world through observation and experiment. And the reason I wanted to read that to you, Michael, is because the key there is observation and experiment. So something is not scientific unless it's observed and then backed by experiments. So I just want to get that common ground with you. Do you agree with that definition?
I think the "and" isn't meant to be a strict "it must be both" type of thing.
Okay, that's your view, and I thought you might say that.
Yeah, and so I'm not gonna. I won't take any one particular definition as dogma.
Sure. Yeah. But I'm happy to use any definition that you like. But you will find that observation and experiment are required. Now, let me explain why. People may find this hard to believe, but we had the pre-Christ days of all the great philosophers, and science was about understanding the natural world, and that's why the Catholic Church got behind science and they invested in science to understand God's creation. So let's not make this debate about religion, but let's just say it was about observing the natural world and then finding explanations for it. And that's where the proper science or the proper premise for scientific research comes from. So I just wanted to present that because I know a lot of people say things like, "Oh, you're a flat earther because you've watched a couple of YouTube clips." No, that's not why I'm a flat earther. But YouTube is very valuable for observation. Very valuable for observation. So don't diminish someone else's work just by saying it's on YouTube. Who cares what medium it's on? But if you're seeing an observation and there's studies and research supporting it, then it's a valuable resource to have. The other thing I want to say is any evidence that I talk about or any claims that I make, all the references that your viewers ask for or you might ask for, Michael, they're all in adherence with the scientific method. And I suggest if your viewers don't understand what the scientific method is, that they go and learn about that, because having written a thesis, I understand the scientific method inside out. I don't know the steps off heart, so don't ask me to do that, but I do know the issues that you can have with studies that aren't adherent to the scientific method. So I just want to say that before I begin. Okay, so let's have a look at the belief of the sphere earther. I've got some props here. So some believe it's a sphere. I've demolished this kiwi fruit. Some believe it's an oblate spheroid. This poor kiwi fruit. Sorry to everyone in New Zealand, but that's the best I could do with an oblate spheroid. But some believe that it's, like Neil deGrasse Tyson kind of believes that southern hemisphere, south equator, is a little bit bulgier than the north. So I don't have pears because I don't like pears, Michael, but I've got an upside down apple, which gives you a little bit of an idea of what some people believe the shape of the earth to be. So they also believe it spins. Yep, so we've got the shapes, we believe it spins, they believe it's tilted, just as you've shown with your earlier discussion about the tilt. They also believe that it rotates around the sun, which is 93 million miles away. So let's have a look at that definition of science. And I call it the limbs. There's two limbs. The limb is the observational test, and then there's a scientific experiment test. So let's just have a look at the first limb. Let's look at observation, okay? So where is the curvature? As a human being, imagine you had lived in a box for 18 years, you didn't go to high school, you walked out and you walked to the seashore and you saw a horizon. Where's the curvature? Has it been observed? We've got some footage now from weather balloons. Where's the curvature? The horizon is always at eye level, and I know you're going to argue with this and dispute it, but you'll hear my response to that. The horizon is always at eye level. At 158 or 125,000 feet, it's at eye level. That's not how it works. If there's a sphere, it should visibly be falling away from us. We should be able to see the curve. Neil deGrasse Tyson actually says, he goes on record saying that the jump, that Red Bull jump, I can't remember the guy's name, that Red Bull jump, I just want to show you something, because as I said, I'm trying to present some form of evidence. That Red Bull jump, where we had that gentleman jump from 128,000 feet, he had a curvature of the earth in the background. But when a weather balloon goes up to the same height, you get a flat earth. Neil deGrasse Tyson went on record and said, in lower Earth orbit, you're not going to see a curvature. You're just not going to. And he admitted that was bullshit, and he admitted that was a wide angle lens. So where's the observation of this curvature? Where's the test on the first limb in the scientific definition? Why haven't we not seen this curvature anyway? And okay, the next one is the spin. The Earth spins. Why don't we feel it? 1,000 miles an hour. Why don't we? And I'm using miles because I know that's the units that you guys understand. Mine is kilometers, but it's 1,000 miles an hour. Why don't we feel it? Because we're inside the frame of reference. I believe you guys believe the atmosphere rotates with it, and is held down by gravity. Therefore, we don't feel 1,000 miles an hour. But where's that observation? We don't observe that. Can we observe the Earth's tilt? Can we observe the tilt? You've tried to put that through with the sun's rays. I think that's a great way to try to explain it. Again, on the 20th of December, we're going to prove that wrong. But where's the tilt? We don't observe a curvature. We don't observe a spin. We don't observe a tilt. And I'm going to show you with scientific evidence, using your own scientific evidence in the next block that I'm allowed to allocated, that even your scientific evidence proves there's no tilt. Okay, now, do we feel the Earth rotating around the sun? That's 67,000 miles an hour. We don't feel that either. So 4 claims you guys make: the curvature, the tilt, the spin, the rotation are not observed. So they fail on the observational limb. If we're testing the first limb of the science definition, they fail. So I'm happy to hand over to you. We'll talk about the observations before we talk about the scientific evidence. But I've got a little bit more, but I think my 5 minutes is up. I've got more about...
You have a minute.
A minute, okay. So let's have a look at that. That's what the sphere Earth believe. What do flat earthers believe? And is it observed? The Earth is flat. So we observe that from sea level. We look at the horizon, it's completely flat. With weather balloons, completely flat. and as I said, Neil deGrasse Tyson said, from low Earth orbit, which is the highest we've ever gotten, you're not going to see curvature anyway. So he supports the view that curvature cannot be observed. It's flat. So is a flat Earth observed? Yes, it is on that point. The Earth is stationary, so we don't feel any movement. That's an observation that works in our favor as well. The Earth is not tilted, so the flat Earth is not tilted in any form or shape. And I'm going to prove to you with your own science that even on a sphere, it's not tilted, if you believe the sphere exists. So the sun revolves around us, okay, not us around the sun. And I've spoken about that, and we're going to readdress that on December the 20th. But more importantly, it explains the oscillation of the sun spinning between the two Capricorns. It explains the solstices, it explains the equinoxes, it explains the seasons. Okay, it explains why there's 4 seasons in the north, 4 seasons south of the equator, but there's only 2 on the equator. How does it tilt to the Earth? Am I time up?
Yeah.
Okay, sorry. And I'm going to talk to you a little bit more about some time-lapse footage if I have time. But the observation team, so testing the first limb of observation, for the sphere Earth fails measurably. For the flat Earth, it completely adheres to what we observe. Over to you, Michael.
Okay. Let me make sure. So I'm going to present to you. I have the wrong window here. So, oh, I know why that was from yesterday. Let me close that window. I use an incognito window when I do this, and I'm like, I have 2 of them.
That means nothing to me.
That means nothing to me. Oh, it's so that it doesn't have any of my private information.
Okay, gotcha.
Gotcha. So, all right. Let me set up let me share to you the screen so you see what I'm doing. I got you. So I'm going to respond to your 4 topics. I won't respond to Neil deGrasse Tyson. He's not here, and he says the Earth is a globe. So that's
I'm happy to debate him. I'm happy to debate him. If you're a friend of his, I'm happy to have a debate with him. But I know he won't.
Well, he doesn't debate flat earthers.
Yes, we know that.
And apparently, Eric Dubay doesn't debate me. So
I don't. You know what? I don't care what thought leaders of flat Earth think. I respect their views. I don't really know what Eric Dubay thinks. I don't know what Mark whatever thinks, and this other Nathan guy. I don't know. These are the big names I get all the time.
Yeah.
I don't care or know what they really think. I make my own mind up.
All right.
Okay. So what am I looking at here?
So this is just to start. This is where I go as my first stop when I'm looking at the definition of science.
Sure.
This is the website Berkeley has called Understanding Science. So this is a comprehensive coverage of science. So
great. So where's the definition? What definition do they use?
This entire website is the definition.
Just one definition.
So, there isn't just one definition to science. It's not dogma. So that's kind of their point.
Okay, but let's have a look at that first sentence, Michael, right there. To understand what science is, just look around you. Is that another way of saying observation? What do you see?
Yeah.
What do you see? So the first intro is about observance, but I'll shut up now. Sorry, over to you.
So, all right. So oblate. So you're asking about the oblateness of the Earth. Let me get this. There it is. Okay. So that's been measured, and measurements are part of the subset of the observations. So I have here 6 different measurements of the radius of the Earth, and every one of them shows that this A, that's one radius, and the B is the other radius. One is polar, one is equatorial radius.
No disagreement on that. That's the distance to the equator.
So
that's the distance to the equator.
From the geometric center of the Earth, the sphere Earth, to this equator, and from the geometric center to the poles. That's what these 2 things are here. So each one of these shows, this particular one didn't give a sometimes they give the 2 specific numbers, and sometimes instead they give a flattening ratio, and that's what this is. This is the flattening ratio here.
Yes.
So Bessel is one of the measurements that many countries have used and still do for their actual surveying foundational work. But the most important one here for me, because it's in the United States, is the transcontinental triangulation of the American arc of the parallel. And this is a very accurate one. So 6,377 912 meters.
Mm-hmm.
6 million, not 6,000. So these are on mc2.net/r. So the measurements of the oblateness of the Earth have been done.
And that's not a measurement of the oblate. That's what you call the radius, and that's the distance I totally agree with from the center of the Arctic Circle, dead center, to the equator.
So
that's the distance. And from the equator to the ice rim, that's the distance.
Hold on, this is my turn.
Sure. Yep.
When I'm all done, we'll have the open discussion. So, so that's the observation of the oblateness. The spin of the Earth, you can without any measurements, just observing it, you can look at the two celestial poles, the North Celestial Pole, the South Celestial Pole is evidence of either a spherical Earth rotating or a spherical Earth could be stationary with some sort of a fixed thing at a large distance above the Earth. So independent of other things, you can't tell which is rotating, but there are other ways to identify what is rotating. An optical gyroscope will do that. So these are peer-reviewed, published scientific papers, measurements of the rotation of the Earth with high-quality, very precise instruments. So one I like a lot here is the sensing Earth's rotation with the helium neon ring laser operating at 1.15 micrometers. Successfully obtained unlocked rotation sensing of a large ring laser gyroscope in the infrared regime rate biased by the Earth's rotation alone. And that link right there is on there. Mm-hmm. So you can get that mc2.net/spin. There's about 16 on here. There's another one here. Detection of the Earth's rotation using superfluid phase coherence. They took liquid helium, put it inside of a toroid with a way to measure the rotation of the fluid through there. And liquid helium at that temperature has no viscosity, so it doesn't have any friction. So the rotation of the Earth is the only thing causing it to rotate. Measured rotation of the Earth. So there is a measurement, which is a subset of observation of the spin. The tilt of the Earth, well, that would be the seasons changing. So I don't know how that once we've established the Earth is spherical, which those measurements did, then the tilt is something you can examine because you have both celestial poles, and then you can see that the precession of you have a different equinox and solstice different times of the year. That's where we know that the tilt comes from. And then let's see, we're talking about the rotation around the sun, and well, we know that because it takes a year. We've measured the distance to the sun using radar. And then we talk about things like 1,000 miles an hour. How come we can't feel it? We can't feel that because the rotation is not 1,000 miles an hour. The rotation is 0.0006 RPM, and the human body can only feel much more than that. So the human body, that's below the ability of the human body to feel. That's why we don't feel rotation. Rotation's measured in angular units per time, not linear units per time. So, and same thing around the Earth. The Earth rotating around the sun or orbiting around the sun. It's much lower angular change per time than the rotation of the Earth, which is still below the human perception of rotation. And finally, you did mention eye level, the rising to eye level. That's not it. Oh, there it is. There we see the shape of the Earth. This is 1972 picture here.
Yep. Composite, right?
No, this is a photograph taken on where'd it go? Taken on a medium format film camera and developed in a dark room. And people can go see the negatives. They're still on display in a museum. Well, not on display. You have to have an appointment, but you can go see the negatives. And horizon does not rise to eye level. You can measure it again. And I did it myself right here. This photograph was taken by me on an airplane when I flew back from Alaska 2 years ago. So you can see right there, these horizontal line across there is eye level, and that circle is the moon. So the moon didn't even rise to eye level, and you can see it's a little faint, but you can see below there, but below the square, the actual clouds that is above the horizon. So the horizon's even farther below.
So why don't we move your box down?
Yeah, if you move the box, you can't
move your box down to have the main line on the horizon so it's accurate.
No, it's eye level. So this the line, the horizontal line is eye level, and that's my time. There we go.
Yeah. Wonderful.
All right.
Okay. Thanks for that. I'll get into my 5 minutes straight away because we don't have.
Well, no, we have 10 minutes open discussion.
Okay, good. Okay, so do you want me to respond to that, or is there some questions that you want me to answer, or some viewers have questions?
Well,
we've spoken so far.
Let's do the us talking, and then we can see what the viewers have after that.
Sure. Okay. All right. So radius. You brought up the radius, and there's no dispute. I agree with those numbers. I always get this wrong, but Eratosthenes.
Eratosthenes.
That's the one. Eratosthenes. Yeah. His experiment was fairly close, not accurate, but fairly close many years ago. So we don't have an issue with that. You call that the radius of the Earth. I call that the distance from the Arctic center to the equator, from the equator to the ice rim. That's what I call that distance. So there's no dispute on that. Now, optical gyroscopes I find always very interesting, and they come up a lot in discussions. You have to have the belief, or the premise has to be that the stars are stationary for that to work.
Optical gyroscopes don't look at stars.
But they're fixed to a point. They're fixed to a celestial body.
No, they're not.
Yes, they are.
Optical gyroscopes don't have. They don't look at stars. They have nothing to do with stars.
Okay, so tell me what's the point of reference then?
There is no point of reference.
What are you fixing at? What are you fixing at and saying the Earth is rotating?
Nothing, because rotation is absolute.
Explain the methodology.
So the methodology of how these optical gyroscopes work.
Yeah.
The optical gyroscopes use the Sagnac effect, and they tend the basic version is a square or rectangle where they have at one end a prism that splits the light beam into two, and then the light travels in opposite directions around the rectangle, and then once it's gone all the way around, it's rejoined. And presented on a screen in the old days, but now it's done. It's just measured on a computer with a sensor, and the out of phaseness of those two light beams tells you how fast you're rotating. It doesn't look at any stars. There's no reference to any stars necessary.
The methodology that I must be confusing with that one is the one where they fix some telescope to the stars.
Yep.
Do you understand? Do you know what that's called?
I have one of them right here.
What's it called?
Transcontinental baseline and the rotation of the Earth measured by radio interferometry. So this particular, just one of the several that I have on here actually looks at stars.
Okay, got you.
But
now
the rest
let's talk
do
about
not.
that. So a lot of the responses I get about the spin and the evidence that's predominantly given is fix this telescope to a star.
But that wasn't my point. So I don't care if you address that point. I brought up optical gyroscopes and also using superfluid phase coherence, a liquid helium inside a toroid with a measurement device to measure rotation.
So we're doing experimentation that doesn't fit an observation. That's what we're doing, right? Basically what you're doing. You're giving me information of experiments that don't marry up with observation. So
the observation would be, we see two celestial poles and we see it either the Earth is rotating or and it's spherical, or there's some sort of a firmament type thing would be some people's explanation that is rotating around us. So then,
Correct.
so that's the observation. So then we can test to see, because we can measure absolute rotation. Let's measure to see if there is any absolute rotation, and that's what these things
so
are
the point I'm
measuring.
trying to make is what your devices are interpreting as the Earth spin is not actually the Earth spin. So Polaris is the central star. That's fixed. Yep. Sigma Octantis is the southern version of that. That's fixed. And stars are rotating around those two fixed points. So where you're viewing through these devices that the Earth is spinning based on whatever celestial bodies or gyroscopes or whatever, it's not a fact. Let me explain why. Stars in the north of the equator and south of the equator spin in different directions. How does that work on a sphere Earth, right?
As absolutely necessary on a ball, on a sphere. That is how it must work on a sphere.
So I'm in Sydney and the Earth is spinning in one direction. I look down, stars are coming with me. I look up, the stars are going against me. How does that work on a spinning Earth? How is your observation working on a spinning Earth? Please explain that to me.
That's how it has to work.
Please explain that to me. The stars are rotating in different directions, right? How does that work if the Earth is moving in one direction?
They're actually all rotating in the same direction, but from the point of view of a person, on the Earth, they appear to be in the opposite celestial poles. The prediction of a flat Earth with maybe a firmament over, as some people suggest, would be that there would be a central point at one spot, like the North Pole, but the south, when you look south, you would not see a single point. You would see the stars, the farthest south, you would expect to be moving the fastest. They'd be purely lateral, and you'd see them moving the fastest.
They all move at the same. They all move at the same pace.
I know what the observation is, but I'm saying the prediction for flat Earth.
There is a central point. You're arguing that there isn't a central point. There is, and it's called Sigma Octantis. Look it up. Just as we have Polaris in the north, we have Sigma Octantis in the south. Yep. But it's not viewable from. Sorry. So I know it's my time, but I'm happy to discuss.
No. This is the 10-minute back and forth. And I didn't start the timer. I'll start the timer now.
Apologize.
8 minutes.
Yep. So there's a fundamental issue. If the Earth is rotating in one direction, so let's say at the equator, you get time-lapse videos showing the stars moving in different directions from the equator.
That's what's predicted on a globe. That's what's predicted on a globe.
How is it predicted on the globe if you're moving in one direction? So I'm moving in one direction. So say I'm in Sydney. Okay, let's say I'm closer to the equator. Are you with me?
Yeah.
Come with me, Michael. I came with you, right?
I'm coming with.
Just say I'm just south of the equator. I can see northern stars and southern stars. Right? I'm facing south. I'm looking out into the night sky. And I can see stars rotating in one direction. And then you look further up and you can see stars rotating in the other direction. How is that possible on a spinning Earth? If you believe stars are fixed and they're light years away and the Earth is spinning, please explain that to me.
Well, I don't think that stars are fixed.
So stars are now rotating around Polaris. There's a firmament then.
No, I don't think that the stars are fixed. There's documentation of the stars moving.
Right.
But yeah, that is predicted. If the Earth is rotating once a day, and the stars are far away and moving in relation to us very little, then when you look north from above the equator, you should see a central point of rotation. And when you look south of the equator, you should see a central point of rotation moving the opposite direction of what you see in the north. That's the prediction for the globe.
How does that work if you're spinning in one direction?
That's just
I'm just asking. I'm not being a prick. I'm asking
I know.
Simple question.
I know the problem here.
It's mind-boggling that we can spin in one direction, but stars are moving in opposite directions. It's just a simple question. Because I haven't even started talking about the stars.
Wait till I get to the stars. Tony.
It's predicted. You're saying it's predicted.
It is predicted, yeah. And here's it's
okay. We can shelve that. You can come back to it on another day.
The reason I'm at a loss for how to describe it because it's such a basic concept.
No. Well, make it basic for me. Make it basic for me. Let me explain. Okay, let me explain this. While you're thinking, I put a sock on the ground and there's a light bulb right above me, right? A down light. And I just stand off center from both of them, right? I look down, I look up, and then I start spinning. So I'm the earth, right? Am I not leaving the light globe and the sock away to my right? Are they not moving in the same direction as I'm spinning?
No, actually.
What do you mean? I'm doing it right now. I can look
that's perfect.
I look at a shoe and a light bulb and I'm turning and they're both going over my right shoulder and coming back over my left.
Yeah, but all right, look up and tell me, is it turning clockwise or counterclockwise?
Okay, so I'm looking up, right? I'm turning around.
Yeah.
That's going clockwise. So the sock.
The sock is when you look down.
Yeah,
look down and turn. The sock is turning. The sock is turning anti-clockwise.
You're making me spin around like a ballerina. It's the same thing. You stand up and do it. Michael, stand up and do it. Please stand up and do it. It's your argument. It looks like a freaking ballerina.
We all watch you do it.
Just do it.
And you did
just
it.
do it.
Oh my gosh.
Look, there's the earth. There's the earth. And it's spinning. It's spinning. And they're both going around to the right. Just stand up and do it, please. I beg you. Do it for me as a favor.
When you look up, all right, if I turn this way.
Right.
The ceiling is turning anti-clockwise.
Correct.
Okay.
No. Yeah, it's going that way.
And now I look this way.
The clock goes that way.
I went this way, right?
You're turning anti-clockwise.
No. To my orientation, as I view it, the ceiling is turning anti-clockwise when I do this. Okay, now I'm gonna look down and I'm gonna turn the same direction.
Right.
And the floor is turning clockwise.
Michael, come on. I'm standing right here. Right here.
We have 400 people watching. We have 400 people watching right now. And
I think 400 people should stand up and do that, and look like a ballerina as well. Stand up, everybody. Point to a point in the ceiling. Put a shoe on the ground and rotate in one direction.
And does it go?
And just tell me, my shoe is disappearing on my right-hand side, right? So is the light bulb.
No. Is it clockwise or counterclockwise?
Okay, I'm spinning anti-clockwise, right?
No.
Like a ballerina.
Tony, it doesn't matter. Don't tell me what direction you're turning. Look up, and from your perspective, what direction is the ceiling turning?
Okay, so have a look which direction I'm spinning, right? You call it what you want. This is anti-clockwise, right? And I look up at the ceiling, that's going clockwise.
Okay, now look down.
Going clockwise.
Now look down, your shoe is going anti-clockwise.
My shoe's going clockwise as well.
It's
bothering me. Stand up and do it. Are you just taking the piss? Are you taking the piss trying to make me look like a ballerina?
You should see the chat. They're like, Tony.
I don't care.
Tony.
I don't care. Michael, I don't care about the chat. I'm looking at the downlight. And I'm looking at the shoe. No, Michael, I don't care. I don't care what people say about me. My feelings aren't hurt. I don't care about their feelings. They can spew whatever they want. But I haven't even started talking about your spin yet. I'm just responding to your comments.
Where's my? I don't have. The kids take it. My wife puts it over there. All I have for a globe in here is.
All I need is this. Viewers, while Michael is pulling out his bong. Is that a bong, Michael?
That is. My kids gave me this for Father's Day.
That's fantastic.
It is a decanter, and I have Crown Royal in it. So yeah. So if there is rotating
in one direction.
Yeah, then looking this way, the clockwise versus counterclockwise is going to be the opposite from up there.
Right.
So
PhD
Tony, who's also Australian, is doing a ballerina dance.
Okay, let me say this much, Mark. Okay, all viewers out there who are not agreeing with me, do this. Go and research the directions of the sun, the direction of the stars. You'll find out they're in opposite directions. That's not debatable. Yep, you'll find that. But then you'll also find that the Earth only rotates in one. You know when it would work? Your theory would work if the hemispheres rotate in different directions. That would be wonderful. I'd love to see that. But just do that. It's up to you. You can smile and laugh about it all you want. I'm telling you logically that you cannot have an Earth spinning in one direction and two stars that you believe are being fixed in opposite directions. It doesn't work. It doesn't work. But we can move on. We can agree to disagree. I've done enough dancing for you. Like I've done enough dancing for you for one day. Come on.
Yes, and our time is up on that. Do you know Wolfie
cool.
6020?
Sorry?
Do you know Wolfie 6020?
No, explain that to me, and I'm happy to look into it. What's it called?
A guy who goes by Wolfie 6020.
No, I don't know him. No,
you don't know.
Honestly, I don't know many people besides the few groups I'm on.
He's Australian.
Yeah, where's he from?
Australia.
Yeah, that's a small place, isn't it? It's the size of the USA. It's the size of the USA. It's like saying someone from New York is from LA.
Sorry, Wolfie. He's probably. I'm not even going to guess.
Okay, what's his question?
He says, I got a request to ask to join to address the horizon rising to eye level.
Oh, beautiful point. Can I get to that or not?
Hold on. I'll keep reading. I live in Sydney and have lots of astronomy time there too. Yes. So we could bring in Wolfie if you wanted to talk to Wolfie.
No. All I'm going to say to Wolfie is this. Wolfie, go to any formula, any sphere Earth formula, and you can do this too, Michael. Go to any sphere Earth formula and look up distance to horizon and look at the formula, whether it's the calculus formula, whether it's the standard Pythagoras formula. Please show me, tell me what you get, Michael, please. I'm not going to say a word. Please.
The distance to the horizon?
Distance to the horizon, the formula behind it, and bring it up on screen, please.
All right.
That's all I'm going to do, and that's all I'm going to say.
Yep.
Just bring it up. Bring it up, buddy. That's all I'm asking for.
Yeah, you just Google Andrew Young distance to the horizon is what I'm looking up. So I got it here.
No, not Andrew Young. Just anything. Just any distance to horizon formula. Yeah, any calculator. Any calculator. Just bring it up on screen, please. Bring up the formula.
I'm working on it. I got it. They're seeing it now, and I will share it to you so you can see.
Thank you very much. Because what you will find is that eye level is in every single formula, and if it isn't, it's not an accurate thing. So let's have a look. Where's the formula, mate? Typical, we just have the formula given R, so radius of the Earth.
This is
square root of the height. Move. How do I move this?
This is refraction with
the height. Okay, you
simple refraction.
That's fine. You can talk about refraction, but have a look. Square root. See what it says? H feet.
Yeah, that's the observer's height.
Eye level.
That's the observer's height. Yes.
Exactly. But no, it's not his height. It's height to his eye level.
Yeah.
Bring up as any other formula you like, as many as you like. It will always have the height of the eye level.
That's of course. Look, you have to have that.
Yeah, it's a sphere Earth. And why is that? Because it's always at eye level. Whether you're at the top of Mount Everest, whatever your eye level is, if you're at the seashore, if you're 6 foot, and your eye level is, let's say,
but
5.
It's not.
Well,
but it's not at eye level. Here's my measurement.
Yeah, it doesn't matter though. But it doesn't matter, Michael. If I was standing up and looking out that window, that horizon is going to appear lower, right? If I'm sitting down, it's going to appear like it's. You can't just put a diagram onto a screen. Look at the scientific formulas that are used.
No.
Here's the deal. Formulas, every one of them will have.
This is a measurement, so that horizontal line across the screen there is eye level.
And I respect that. I respect your point of view, but it's not what the science shows. It's not what your own science shows.
Actually, this is my own science.
But this is your observation. This is your photograph of an observation, right?
Yeah, this is a measurement. So I measured how the eye level. So the horizontal line across there is eye level. And the moon is all below eye level.
I'm sorry, I'm just looking for 3 formulas. I've got a photograph somewhere of 3 formulas, and I'm trying to find it. And every single formula, no matter what you use, has eye level on it.
Yeah.
So how can that be if it's not at eye level?
I'm just showing you a measurement that the horizon did not rise to eye level.
This is your measurement. This is your idea of an observation.
Yeah.
It's not a scientific formula. It's your idea of an observation.
This is scientific measurement.
No, it's not. It's you putting a box on a screen. I can move that box down to the horizon, and it would be more accurate.
You can't move that box to the horizon.
Why not?
Because that box is eye level. So if I
who put that box there?
The measurement device did.
Okay, so let me just say this.
So, and I can show you.
Let's agree to disagree. Let's agree to disagree. But every single formula for distance to the horizon has eye level in it. Let's disagree.
So here's another one. You see, this is a theodolite. This is a very, very accurate tool. And you see that horizontal line across there?
Yes, I can. I've seen this stuff before. Yeah.
That's eye level.
Yeah.
And the horizon failed to rise to eye level.
But okay, use a formula. Just go to a calculator online and type in distance to and put in your eye level and see if you get 3 miles from the seashore. You will. I'll tell you that right now. You'll get 3 miles. And if you go to the top of a lighthouse at 75 meters, you'll get a further horizon. And it's still at eye level. It still asks for your eye level.
But oh my gosh,
the science shows you it needs eye level.
That's not what that's showing.
Michael, okay, I just showed you this. I showed you this.
What is that? Hold on.
That's the weather balloon, and that's the Red Bull jump. Oh. Can you see that?
No, hold on. I'm sharing my screen so people don't see that. Hold on a second.
Okay, right. So I showed you this earlier. That horizon is still at eye level to the camera.
You don't know the angle of the camera. So you don't know where eye level is.
But at 125,000 feet, it should fall away by that same amount almost.
Tony, if I point a camera at my feet,
yes,
is that camera pointing to eye level?
You're pointing at your feet.
Yeah.
We're not talking about that. We're talking about distance to horizon.
No, here's the deal. If you can't take just any old picture and know where eye level is on that picture unless you're hold on, let me finish my sentence here. Sure, unless you're certain that camera has been oriented so that the center of frame is perpendicular to the downward direction. That's the only way to do that, which is what I showed you. That's what that theodolite is.
Okay.
So lacking that, just any old camera taking a picture without an actual measurement, you don't know where eye level is.
What about our natural anatomical camera, our eyes? When you're on the seashore, our eyes.
What is the margin of error of that scientific measurement?
No, but there is no margin of error. Use your own formula and put in your height.
Sorry.
And
there is a margin. Our eyes are not very precise measuring devices.
But let me explain this to you from a medical perspective. Remember, I did my thesis on cranial nerves. Cranial nerves feed the eye. They feed the lens. They feed your eye. They feed your eye muscles. So I know all about the cranial nerves and how they work. So let me explain something. The horizon is it's a visual perception of where your eyes converge. You can no longer see beyond that point. That's what the horizon is. That's where your eye level is. So, and the higher you go up, the further that point gets before your eyes have this visual phenomenon where they converge. It's also how perspective works. It's not open for debate.
Right,
you can say it's not.
And where's the peer-reviewed science supporting that? Then I guess.
Yeah. Is that one of the references that you would like?
Yeah, that things disappear apparently.
Absolutely. We don't have an infinite visual field. We don't. It depends on our altitude. And depends if we're using magnification. You can bring the sun back into the sky with magnification. It's impossible on a sphere Earth.
Never seen that.
I can show you that link too. So let's do that too. Sun, rise to eye level. So look, we can move on, but I'm just saying to you this. Every formula that calculates distance to the horizon requires eye level. So it's up to you what you make of that. Okay, it's up to you what you make of that.
Of course. All right. Let's.
So can I address your points from earlier because I haven't had the chance to yet.
Well, yeah. Well, hold on. We kind of went through our 10 minutes here.
Okay. Cool.
We got a couple questions if you don't mind from the audience.
Sure.
Let's see. Kang024 says from New Zealand says the sunset clearly shows the geometry of the Earth. The sun does not change in angular size during the day, so it's nothing to do with perspective.
What's perspective? So, I'm sorry, what's his point? Is he talking about the degrees of sunrise and sunset we've discussed? What's he talking about?
Let's go. Perspective is things get smaller, they appear smaller as they get farther away. So uniform reduction.
They get lower in the sky, right? Remember my Polaris example.
It's a reduction in angular size with increasing distance. So
perfect definition.
Hold on. The angular size between the horizon and the sun, that is a size, and that size gets smaller with increasing distance. So that's perspective. Right. Everything gets uniformly smaller, and it can be calculated using the...
Depends. It depends.
There's a formula for it.
It depends
or you
as
can
well.
just do triangulation.
It depends if you use a proper filter, which some of the ones that I've got will show you. Yes, you can see that. But there's also scattering. The sun, before the sun disappears 6,000 miles away, which is our perspective from sea level, before the sun disappears, there's a lot of dense air. There's a lot of scattering. There's a lot of things in the air that can cause the sun to appear bigger. It's not always that obvious. But there are enough clips online for you to look at.
I want to see the peer-reviewed science on the atmosphere making the sun appear bigger.
You're talking about an observation. You're not talking about a peer review. You're talking about an observation. There's no peer review that shows this is what's happening. I can show you observation after. Okay, let me ask you this question, because it's in answer to this question as well. Can the sun, listen to this carefully, can the sun set, okay, 6 degrees north of south, can the sun set 6 degrees northwest of north? Okay, so can it set here? Yeah. Can it rise 6 degrees east of north? Am I saying the right thing here? So can it rise? Can it set here? So over a period of 6 degrees, can it set and reappear on the sphere Earth? North.
Yeah, depending on where you are and the time of year, yes, I think it could.
Okay, so to explain where. I'm holding a compass. The sun sets 6 degrees west of north, reappears 1 hour later, 6 degrees east of north.
Yeah, that would be, you could do that very far south in the summer, in December.
Okay, with all due respect, absolutely correct. That observation is a time-lapse video from Bardu in Norway.
Yeah, not south, it'd be north. Yep, okay. Sorry.
It's the day after 24-hour daylight ends, and you can see on the time-lapse, the sun moving across the horizon, disappearing away from us, coming back towards us, and getting larger as the day moves on.
Yeah, and you can
that's plain to see, which I will send you.
The same thing happens 6 months later as from South Africa.
No, it doesn't.
South America.
No, it doesn't. No, it doesn't. Sorry. And you can provide that evidence. I'll provide this evidence.
Yeah.
You can provide your evidence.
I do have that. Like
this
I said,
this is filmed in Bali, Norway, and what you'll find is that reference you spoke about earlier.
I have no problem with that. I totally accept that. I don't even need to see it. There's no problem. It completely matches the globe.
How does it match the globe? In what phenomenon does it match the globe? Explain to me.
It's just south of the Arctic Circle, right?
Yeah, explain how it works.
Yeah.
How does that work on a tilted sphere?
Because of the tilt.
Yes.
It works.
Right.
Yeah.
How
does it work? Okay. It's the geometry.
Because I'm going to show you the observation, then I'm going to show you the scientific evidence behind it from one of your sources. That sundial, sun-time source that you mentioned, I'm going to show you the exact same date and what the sun does and how long it stays in the air and how it grows as it's coming back towards you. You can see it rotating. You see it rotating.
Yeah.
It's plain as day.
Like I said, that is the prediction of the globe. So here's the deal. That a lot of flat earthers do this. They have a misunderstanding of the globe.
Okay.
And then they say, this should happen on the globe this way, and then they show something else, but it's been a misunderstanding, and then they say, well, then we've disproved the globe. But what you've done is you've disproved a straw man of the globe, right? So that particular observation that you're talking about is what we expect.
Okay. So will you provide that evidence can you provide the observation and how it works on a sphere? And I'll do the same for a flat earth. It's only fair, right?
Yes.
And you can share it with your viewers. We don't do it now. Yeah. Share it with your viewers. You can do it as a follow-up.
Yeah. All right.
Yeah, that's cool. That's fine. But and please don't say that I have a misunderstanding of the sphere. I was a staunch sphere earther, and I know more about the sphere than most sphere earthers do.
All right. So, Angel.
So can I move on to my response to you? I haven't had a chance to respond.
No, we had our 10 minutes. You had.
But it's my 5 minutes again.
Just wait. Let's get through the audience here for a second.
5 minutes again.
No, I'll give you 5 minutes. We'll go into round 3 in a minute here. So
Okay, cool.
and I'll mute myself or whatever. And so, all right. Angel Garay says, "Can you show us Polaris in your sky?"
Say that again, sorry?
Can you show us Polaris
Of
in
course
your
not.
sky?
I'm in Sydney. I'm south of the equator. Of course not. She may not have been here for the start, but the perspective is once you move away from under Polaris and you reach the equator, it's no longer, it's below the horizon. Cannot see it at all.
Can you show the geometry for that? Like,
How do I show that?
Do the
How do I
geometry.
show that? How can I show you that on this format?
Well, paper. I like using paper.
Look, the geometry is very easy. The geometry is very easy, Michael. We don't disagree. We don't disagree.
I think we do.
But no, we don't disagree. Do you move it when you're moving away? Okay, just go to any calculator online and calculate the distance or the height of Polaris in the sky from your latitude. That you will find the formula has latitude in it.
There's the flat Earth. So here is.
Right, so let me explain. Let me explain. No laughing at my drawings here.
Oh, my drawings are bad too. All right, here. How about this?
Hang on.
I'm winning. I got mine drawn first.
Okay, you got there before me. Now you're directly under Polaris, right? So it's above you.
Yeah, that's the North Pole there.
Directly above you. Now go to any latitude. Just pick any latitude.
I'm at 45 degrees north.
Okay,
put that on there.
So go 45 degrees away from it, perfect angle. And draw a line to 45 degrees.
Right there.
Okay, so does Polaris appear lower in the sky to you?
It's 45 degrees. Now, here's the deal.
Beautiful. Okay, now, to answer the question of the viewer, if you move that to 90 degrees, it's now Polaris is...
Hold on a second.
Yeah,
there is 3105 miles. That's how far I am from the North Pole.
Yes.
Okay, now, to go to the equator is double that. Okay, so I'm pretty close to 45. It's an estimation, but I will draw double that distance.
You won't see Polaris. Polaris will be on the horizontal line. Polaris is no longer visible, which answers the question of your viewer.
But now here is the equator, right there.
Okay. Yep, and Polaris will be on the end of that horizontal line.
I'll draw a line now to where Polaris should be according to the flat Earth prediction.
We don't disagree on this. This is a sphere Earth and a flat Earth common ground.
All right, here we go. There is the prediction for flat Earth.
But that's
right
not 90
there.
degrees, my friend.
But
It's not 90 degrees.
I'm not talking about what we observe. I'm talking about the prediction. This is the prediction for flat Earth, right? So
no, it's not.
So I am 33,000.
That's words in my mouth. That's not a prediction for flat Earth. I'm telling you, and I've said it several times.
Well, then tell me
the
geometry. Then how do we do the geometry?
If you're at the equator, Polaris is on the horizontal line.
But how does the flat Earth? But how does flat Earth predict that?
I just told you before, with the I Dream of Jeannie thing.
Yeah.
That's Polaris at the end of my fingertips. The further you move away, when you hit the equator, Polaris is on the
that
horizontal.
angle gets smaller, but it never gets to zero.
Yes, it does. At the equator, it does. At the equator, it does.
Not in geometry.
Michael, you can't see it. You cannot see Polaris.
I understand that you can't see it, but there's no geometry. There's no geometry to support that, though. I'm asking you for the geometry for that. Okay,
so here's the geometry. You ready? That second point, is that the equator or not?
That's the equator.
So you're now 90 degrees away from the center of the Arctic Circle.
Yeah, so twice as far as 3105.
Great. So where is Polaris now in your idea?
In reality, we observe it.
Where is it in your belief?
The observation is that it's at 0 degrees elevation, and the prediction on the globe is that it's at about 0 degrees
and we don't
elevation.
We don't disagree.
So
I'm agreeing with you. At 90 degrees, so at the equator, Polaris is at the end of that horizontal line. I'm not disagreeing with you. I'm not disagreeing at all.
Okay, so here's the deal, though. I can measure any night. I can measure the angle to Polaris is 45 degrees, and I know
it won't change. It's 45
and
degrees.
I know that I'm at 3105 miles away.
So now, Double
Yep,
that.
62.10.
And you're at the equator.
Now I can pull up a, we can do a triangle calculator here. And we can see the prediction for flat Earth, for above a flat plane.
I'm telling you what that prediction is. Polaris drops in the sky and continues to drop till you reach the equator, and it's no longer visible. It's underneath the horizon.
Well, then, can you give me the math?
What other flat earthers say.
Can you
I
give
don't
me
care what other flat earthers say.
Okay. Can you give me the math? What's the formula to predict that?
Michael, you just showed it. You just showed. Okay.
I didn't show a formula.
Okay,
this is just a drawing.
I'll get your answer. Maybe if I can get a statement in, I might be able to answer you.
Yeah, go ahead.
So now hold that up. Hold that up. Hold that up. That's a great drawing. Far better than my shit. Okay, so you're a 45-degree latitude, which makes your angle of elevation 45 degrees. There's no dispute there. Now, double that distance, and you're at the equator. What happens to that angle? That's an incorrect angle. That's a false angle that you've got there. What actually happens is, and I'm going to do it in red. If that's the equator,
I just doubled the distance.
Yes, now you're at the equator, but you actually haven't correlated the reduction in the angle. Let me show you where Polaris is.
It's a smaller angle.
Now let me show you where the Polaris is. This is disgusting, this drawing. Sorry about this. Okay, so this is what happens. I've done it in red. So this is where you live. This is your latitude, right? 45 degrees. And you double that to the equator, and Polaris is now here. Yeah, but hasn't sunk, but it's now no longer visible. That's what happens.
But did Polaris move? Is it in a different place?
Doesn't move.
So draw a line from Polaris, which did not move, to the observer.
Mm-hmm. It's there in red.
No, but that's a different Polaris.
No, it's not.
Point to Polaris.
No, it's not. Okay, let me tell you something.
Point to Polaris.
We've had this debate online, you and I. And I calculated the height of Polaris using these figures as 6,000 or so miles, which is exactly how high we say the firmament is. Polaris is fixed in the firmament. Now, we had this debate, you and I, already. So let's go over ground again. If you double your distance from your latitude, Michael, let's be honest. You are hitting the equator. Polaris is not. Are we going to argue that Polaris is visible from the equator? No, we're not going to argue that.
No, I'm just doing the geometry.
And I just did the geometry.
It's this. There's only one Polaris, not two.
Correct. Okay, let me explain.
So I draw the line from Polaris to the observer.
No, but your line is incorrect. Your line is incorrect because the angle continues to drop, and when you reach the equator, it's zero. It's zero.
What you're doing is you're shoehorning observation into geometry.
Please let me explain. I challenge every one of your viewers to do this tonight. Please, I challenge your viewers to do this tonight. Walk out into your street if you're not going to get mugged, okay? And just stand underneath a street lamp. Stand under a street lamp, and then walk backwards as far as you can. Right? Walk backwards, run. I don't care what you do. As far from that lamp, look back at that lamp. Is it now lower in the sky or not? Of course it is. But the lamp hasn't reduced in height. It's a perspective issue. It's a visual. Michael, let me finish. It's a visual perspective. There is a point where you are then. You can laugh all you like. It's fact. I'm not disagreeing with you. You're just disagreeing with the logic. So now move as far away as possible so you no longer see that light. It's a perspective. It's the railway track perspective. You cannot argue with that. That's what Polaris is. So if that street light is now Polaris and you move far away enough, you're no longer going to see that on a completely flat ground. Forget hills. You're not going to see that lamp anymore. That doesn't make the lamp fall in height. Of course it doesn't. But it's dropping. If anyone wants to argue with that, drive into a tunnel and have a look how the lights up ahead are lower and they come and get higher as you get closer to them. Come on, mate. There's no argument here. There's no argument. You're asking me to show you geometry. I've explained it logically. I've shown you with my pathetic drawing what happens when you're in the equator. And observation shows you can't see Polaris.
What's the formula?
The formula I don't know off by heart.
Okay.
Let's add that to the list of things I can send you, right? But it has the latitude in it. It's a basic calculus formula. And I think, and let me tell you, don't quote me on this.
It's trigonometry.
It's distance times tan of the angle. This is off by heart. So don't quote me on this. Please, viewers, don't hold me to that. But you can Google it, and I have a decent memory. But try distance, right? Distance times 10 to the angle of 45, and you should get the height to Polaris.
Distance times the tangent of the angle.
Right. Yeah. So if let's go to a 10. Can I just do this quickly while we're online together?
All right.
It might be 10, it might be cos, but it's one of the two. Okay. I didn't commit that to memory.
Okay.
And I'm not sitting here Googling stuff, which I already told you, but let me go online and find out what the formula is. Hang on. And I might be right. I'm not sure.
Are you looking for SOHCAHTOA?
SOHCAHTOA, that's the one. But let's just look at tan, right? Let's type in tan. Hang on a sec. Tan.
So from Minnesota, just while you're doing that, I've measured if the Earth is flat, then Polaris is 3,105 miles high.
Okay, so let me show you something. It's tan. Let me tell you why it's tan. If you type in 90 degrees, so you're now moved 90, you're at 45, you're now moved 90 degrees. Okay, the answer is an error because it's 0. That Polaris is no longer visible. That distance of Polaris to the horizontal plane is 0. Can't multiply something by 0. That's why you get an error. It's the tan. Okay, so let's have a look. Type in tan, 45.
You're saying tangent.
10, yeah.
Yeah. So,
what do you get when you get tan 45? You get the answer 1 times the distance.
You get 1.
Yeah, you get 1 times the distance. And that's how you get the distance from the formula directly from the distance from under Polaris. Look, there's no dispute. We're actually agreeing. You're just asking me to explain the geometry, and I have. So it's one of these things that works on both flat Earth and sphere Earth. So I don't know why we're debating it.
Because here's the deal. You don't start with the angle. The angle has to be the output of the equation, right?
But you're talking about angle of elevation, Michael.
Exactly.
You're talking about angle of elevation. Yeah.
Exactly. That's exactly what.
And that's not 90 degrees away. That's not. That angle there is not. You might be.
So here's
that might be latitude 60.
Here's what you do.
It's not the equator.
The latitude doesn't matter as much as the distance. The distance is the important thing. 3105 if from here. Then this distance here, 6210 is this. 3105 is here.
That's not accurate. That's not accurate, Michael. The point I'm trying to make is not accurate.
Well, what's the distance? What's the distance from the equator to the North Pole?
But you're just written the distance in. Let me explain it again.
If it's wrong, if it's not 6,210 miles, then tell me how far it is.
That's not wrong. Your schematic depiction is wrong. Let me explain.
Okay.
Yeah. 6,200 miles, did you say? Yeah?
Yeah.
Okay. So I've just written it where it should be. So let's look at my disgusting drawing. There's your equator, 6,200. Where's Polaris? Below the horizon.
No, Polaris is still where it was before. It didn't move.
Yes, but visually, it's not visible.
It's not.
That's perspective. That's perspective. That's visual perspective.
So you're working backwards.
It's not something I made up.
You're starting with the conclusion.
No. You're the one that said the latitude doesn't matter. The latitude absolutely matters. Absolutely matters.
The latitude just tells us the distance.
You're drawing a 60% latitude, let's say. You're drawing a 60 degrees latitude and saying that's the equator. It's dishonest and it's not correct. It's not correct. I'm sorry. There's no discussion about this. Sphere Earth and flat Earth agree that Polaris is not visible beyond the equator. There's no discussion about it. We agree. It's your schematic that's incorrect. That's all. Did you really
take physics class? Because I did.
Come on, Michael. Let's not go there. Michael, let's not go there. Let's not go there because I'll destroy you and anyone with physics. But let's not go there.
I'm just
observations.
I'm just bragging to PhD Tony, who loves this book.
Ooh, PhD me? No. I have a master's. I don't have a PhD.
No. PhD Tony is in the chat. He's a.
Got you. Sorry.
He's a different guy named Tony from Australia. There's more than one guy from Australia named Tony.
Okay, but let's put that aside for a minute. It's pure observation. Can I have the viewer's response to this? When you walk away from a street lamp, does it get lower in your perspective as you move away from it? Yes or no? That's all I want.
It certainly does, and
thank you very much. Polaris is the same thing.
It's predictable based on geometry and trigonometry.
Thank you very much. And Polaris is the same thing. The further latitude you go from above the Arctic Circle center, the lower it will appear in your visual field. It will get closer to the horizon until you reach the equator. Then it disappears. That is why Polaris is not visible from the southern hemisphere.
And then but the problem is that the sun never changes in size. It's always the same size.
Don't change the playing field. Are we talking Polaris or are we talking the sun?
The sun. But,
okay, because there's a fantastic clip you can watch on YouTube of someone who puts two sticks between the sun. Okay, and I can send you that link, and it's in Phuket. And I know people hate it, and they don't like it because I don't agree with their rhetoric. But it shows you the sun with a filter getting smaller in size, and actually shows you the sun moving away from the sticks as though it's rotating above the Earth. So let's talk about that observation if we're going to go back to the sun. But remember, I still haven't addressed your response yet. Are you having a drink? Because I might have to pull out my Blue Label Scotch and have a drink.
People said I should have a little bit.
It's past midday now.
It's 9 p.m. 9:40 for me here, so there we go.
Okay, so
all right, hold on.
Cheers, Michael.
Cheers. We were working through the questions from the audience, and we're way behind.
Okay, that's okay because this is a really good discussion. But as I said, I still haven't addressed the scientific response to you. I've only done my observations. So I want time for that. I'm not even done yet.
We'll do that. Let's get a couple more questions in first.
Sure, let's get a couple questions in.
The Sun Express says, why is the Earth not allowed to be a sphere?
No one said that. And Michael, I've said this to you. Ladies and gentlemen, my children are still sphere earthers. I haven't pushed my ideas onto them. They can choose to do their research. They can choose to do their research. And believe it or not, makes no difference. I love science. I'm a lover of science. And when I found out I'd been fed all this bullshit, I was offended by that. I was offended. So I wanted to know the truth. I found out the truth. Now, my truth and your truth, they're going to be different, but there's only one set of facts. True? You can have your truths, I'll have my truths, but the facts can only belong to one person.
One of my favorite albums of all time is Extreme, their third album. Yours, Mine, and the Truth, I think is the name of it.
Yeah.
So, all right. So there you go.
A quick question.
Yeah.
AC/DC. Have you heard of them?
Yeah.
They're in Australia, but they're still one of the top sellers in the US, right?
Great band from England.
Yeah. Bullshit. They're from Australia, mate. They're still top sellers in the US. That blows me away.
Oh, yeah.
But anyway.
What's the name of the most famous Australian rowing Olympic champion?
Oh, fuck, I wouldn't know that.
Michael Toon.
Are you serious?
Yeah.
Are you serious? And you get confused with him? People
Never.
confuse you with him?
Never. All right. The name of the album is Three Sides to Every Story. Yours, Mine, and the Truth.
Okay. Gotcha.
That's,
okay.
A band.
All right. What other questions? Other questions do we have?
We've got Cinnamon Control says Sly Sparkane collected webcam footage of sunrise sunset from Auckland, New Zealand in 2018.
Yes.
And so I guess we could look that up to see if it was north or south of due east and due west.
Well, but that doesn't matter because we're going to do the test ourselves, right, Michael?
Yeah, that's much better for you because
you've committed.
Much
better for you. I know what the result is going to be.
You've made a commitment, so.
But I know what the result is going to be, Michael.
Okay.
I already know what the result is going to be. Believe me, I wouldn't take it lightly and give you my word. Yeah. And then I'd revert back to sphere Earth if I didn't know the results already. And I've already predicted the angle I showed you on the compass is only going to get smaller during the summer solstice. That's it. That's all it is. What other questions do we have?
This next one, Toby.
And are your viewers enjoying this, or are they just are your viewers enjoying this?
The enjoyment I meter based on how fast the chat moves, and the chat is moving fast.
Okay,
So
but are people buying your shirts? Are people contributing?
my shirt sales have not been that good. I'm not very good at designing attire, so I don't know.
Well,
Maybe people don't like it, but
so here's a business idea. Ready? You design a T-shirt with your logo. On the back, it says Naoum, my surname, with the number 1. Done. 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 It's going to sell like hotcakes.
who's gonna buy that? I suppose I could get do that with a screenshot of Witsit after the first time I debated him, because he's like, I gotta take an L to MC Toon.
I don't know any of these people that you're talking about, right? I don't care what their beliefs are. I don't care what they believe. I reach my own conclusion through my own research.
All right, this one here from Toby says that be ready here. He says, what are your means you use to separate a psychotic person from a simple flat earther before going live? This poor man clearly needs help.
Oh, thank you, Toby. I'll seek help if you think that'll make you feel better. What you feel about me means FA. Do you know what FA is?
I know what that means.
Okay, so what you feel about me means FA, my friend. And if that's all you're getting from this discussion, you're wasting Michael's time and my time.
All right. Kiros says, why are all the measurements for thousands of years progressively modern techniques and equipment, from sticks in the ground to survey total stations, not good enough evidence?
Today, the sticks in the ground is still as relevant today as it was back then. In fact, and you say better than I do, Eratosthenes.
Yeah.
Right? How do you say it, Michael, properly?
I don't know if it's proper. Eratosthenes is what I say.
Okay. His experiment was fantastic. And as I said, it's one of these things where it can apply to sphere Earth and it can apply to the flat Earth. You guys can say that the angle projected in Syene from Alexandria was due to this curvature. And that's fine. That's legitimate. I'm happy to buy that. However, if it's a flat Earth, it provides us with far more important evidence than you believe, and that is this. If the sun is directly above Alexandria, we have an angle of 90 degrees. It's 500 miles between Alexandria and Syene. Michael, you can fact check this. The angle between the shadow and the sun was, I think, about 87 or 89. You could quote me on that. I might be right, or might be out by a degree or two. We now have 3 values, which gives us the distance to the sun, which is about 6,000 miles, which is what Zetetic astrology has always said it to be. That sieve experiment that he did is profoundly important in the flat Earth. But as I said, it could apply to both. So we're not going to argue about it. But it gives us incredible information for trigonometry to give us the height of the sun.
Well, the funny thing, I did that 4 times, the same one on both solstices and both equinoxes, with a group of friends and from different latitudes. And yes, when we triangulated and measured the height of the sun,
yes,
at every latitude we got a different height of the sun.
Of course you're going to. Of course you're going to.
Because there's multiple suns?
Because there's perspective.
That is perspective.
We've just spoken about it for half an hour.
I know, that is perspective. All right. So people keep asking, would you mind if Wolfie 6020 came on? And I don't want to bring him on if you don't want
Michael, I haven't finished my response. Do you want me to argue the science behind the failure of sphere Earth, or do we want to leave that for next time?
I don't know.
Michael, I haven't finished destroying sphere Earth yet.
Well,
I haven't finished. I've only just started.
Kind of a pipe dream, but that's...
No, it's not a pipe dream, because I've got science here, your own science, that's going to destroy your tilt. I've got centripetal force calculations that destroys your rotation.
Okay.
I'm ready to go.
All right.
Do we want to hear it, or have you had enough?
No,
I'm happy for you to concede.
This is fun.
No, this is fun for me. I'm having a ball.
No, this
is a long time in the coming, okay. Michael, this discussion.
Okay,
I'm happy for you to concede and go to the audience. Seriously. No, I'm not laughing. I'm not laughing. I'm happy for you to concede.
Right. So,
I'll still love you. I'll still love you if you concede. It takes a man to admit when they're wrong.
Yep. All right. The Sun Express says revolutions per minute, hour, or day are not measured in miles per hour. The Earth rotates once per day. Engine RPMs are not measured in kilometers per hour.
Have they heard of tangential velocity? Have they heard of tangential velocity? Why don't you go to your NASA site? NASA will tell you it's calculated. They use 1,000 miles per hour. They use 67,000 miles per hour. Let's direct that question at NASA. Tell them to stop using tangential velocity. And let me tell you something about some of the science I was going to present. An object in orbit.
You'll get a chance. I'll give you. You absolutely can. Let's just get a couple more questions.
And it's relevant to that question. An object in orbit is always under acceleration. It's called angular acceleration. An object, think about what I just said. An object in orbit is always in acceleration. You can Google that. Your viewers can Google that. They can do the research on it. What does that mean if there's acceleration and there's a mass? Come on, Michael. It's Newton's law.
It means there's a force.
Thank you very much. How are we not feeling this force of rotation? How are we not feeling the force of spin?
Because the accelerations are the same. They cancel.
Incorrect. On a merry-go-round. Let's jump on a merry-go-round, you and I, right? You've already turned me into ballerina. You've already turned me into a ballerina today. So let's jump on a merry-go-round and let's have someone spin the F out of it, right? And let's hold on, right? While it's accelerating, we're feeling the force. While it's at constant velocity, tangential velocity, what happens if we let go? We're going to fly off.
Yeah,
because that circular motion, that circular object is always
very high.
acceleration.
Yeah, a very high centrifugal force. It will throw you off. Yes.
Correct. Thank you very much. That's what happens with the Earth at a tangential velocity of 67,000 miles. We will get thrown off. Let me give you the numbers. It's very simple. An average mass of a human. Michael, are you unimpressed? Would you like me to stop?
No, go.
I'm taking from your non-verbal cues you're not interested.
No, do
I'm happy to continue. Okay, so average mass of a human being, 61 kilograms. If you work out the centripetal force on that mass on an object traveling with the radius of the Earth from the sun, which you guys use, and the velocity, the tangential velocity that you guys use, there will be a Newton force, an outward Newton force of 367 newtons on that human being. What does that mean? That means, let me go back a second. The Newton force, of that rotation is 367 newtons. You can do this calculation yourself. If we want to agree for a minute that gravity actually existed at 9.8 meters per second, right? If we agree, that means anyone who has a body mass of less than 37 kilometers, that's 37 kilograms, will get thrown off the Earth. Think about what I just said.
That's not right.
Think about what I just said. Centripetal acceleration of the Earth's tangential rotation, you can do this on any calculator that you like, will produce a force at its surface of 363 newtons. Anyone who has a body mass of less than 37 kilograms is going to get thrown off this Earth. That's with gravity existing. That's with the existence of gravity.
I don't think
you have to agree with me, but you can go and calculate it yourself. I told you, when I give you science, it's going to be factual. And you can have links to all of this if you like.
Yeah. So
that's your. The question was about orbital mass.
You said centripetal. It's centrifugal.
No, incorrect. There's no such thing as centrifugal force. It's an apparent force. Look it up. It's a fictional force.
So is centripetal
force.
They're both fictional.
No, centripetal force is an actual force. The outshoot of that, the outcome of that, is an apparent force called centrifugal. Look it up. None of this is Googled. All of us from here, look it up.
If centrifugal force doesn't exist, then when you're on a merry-go-round, you would not feel anything. All right, so it does exist. Okay, so centrifugal force exists. And
you're misquoting me.
Okay.
What you're measuring, what the formulas measure, are centripetal force. The apparent force, what you feel when you turn a corner in a car really quickly, that outward force, that's called centrifugal. It's an apparent force. It's felt. No doubt, but you don't calculate centrifugal force. You calculate centripetal force. Look it up. There's nothing here that I'm saying that any scientist won't understand.
Yep. All right. I have it up right now. So hold on a second.
Great.
There it is. And I'll share it to you so you can see it.
Read it to me. You can read it to me.
Right.
Centrifugal force is either known as a fictional or apparent force. Still felt.
All right.
Okay, so go. Okay, how do we calculate? Yep, go ahead. Okay, see that formula? That's the formula for centripetal force. But of course, the same answer comes out for centrifugal. I think you're just missing my point. It's exactly the same. It's the apparent opposite to centripetal. That's the formula for centripetal force. And that's the formula I use to just give you that 363 newtons.
All right. Radius of the Earth, 6,370.
That's not what I'm talking about. I talked about the rotation around the sun. This result will give you 2 newtons. Go ahead and calculate it. I'll wait. That's it. There's your tangential force. Thank you. You got to put the mass. You have to put the mass. Don't worry about that. Put the mass. Put the mass of a human being up the top.
No, you don't. Here's the deal. You can get just the acceleration due to after.
Put them. You need a mass.
But you can get just the acceleration. That's where
no. You need a mass.
0.003 to get the force. You do, but to get
that's what we're talking about here.
Gosh, stop it.
That's what we're talking about here. Force, centrifugal force, centripetal force. You have to put a mass. Either put in the mass of the Earth or put in the mass of a human being. It's 100 pounds. Yeah, the force is negligible. Force is negligible. That's why I didn't mention it. Yeah, force is negligible.
Okay.
Yeah, but what I was talking about, this 363 is not related to the spin of the Earth. It's related to the rotation around the sun.
Okay.
That's where you're talking serious newtons.
Okay.
So you can put it in. I know it off by heart.
All right,
you can put in a massive you can put a 61 kilogram person. You put a radius which is 93 million miles. 93 million miles, because that's the center to the radius to the center of the sun. Okay, you put a tangible velocity of 67,000 miles. You get an angular velocity, and you get a force. I know this stuff off by heart. What have we got? Change the force to newtons.
Yeah, the thing is when you're rotating, when you're
kilos.
When you're in orbit, they're in equilibrium. You've got the gravity of the sun applying to the Earth or to you, and you've got centrifugal acceleration. Both of them are working against each other.
Okay.
And they cancel each other out when you're in orbit. That's Kepler's law.
Where's the proof for that?
That's Kepler's laws.
No, it's not Kepler's law. First, Kepler's laws were thrown out firstly. Secondly, Kepler is attributed in discussing the ecliptic orbit of the Earth around the sun. Nothing to do with it.
So
change those numbers, and you get the same answer I get. I know this stuff off by heart, Michael.
Yeah. So now, anyway, what's the gravity from the
are we moving
the
on
sun?
To gravity? If we're moving on to gravity, let me make a statement.
No. What's the gravity of the sun at that same distance?
No such thing as gravity. No such thing as gravity.
Okay.
And Newton, hang on. Let me answer. You asked me a question. Newton, in his letter to Bentley, you can all Google this and read it. He said, anyone who believes that gravity can exist in a vacuum between two objects it's an absurdity. It's an absurdity to think that the moon and the Earth have a gravitational force for one another, or the Earth with the sun. He called it an absurdity.
Okay,
you can read that in his own words.
And the peer-reviewed paper that calls it an absurdity.
Rubbish. Gravity is the biggest load of BS, which I'm happy to destroy in another debate. Happy to. That will take us an hour and a half.
Okay.
Happy to. All off by heart. We'll talk about we'll talk about Archimedes. We'll talk about the density column. We'll talk about the periodic table, all from memory. You know, I don't need to worry about it. We can do that now. We can go for another 3 hours, Michael. If people are contributing and buying your shirts, I'm happy to stay. If they're not buying, not making money, I'm not interested.
All right. P. Barnes is asking, Tony, in your model, what mechanism speeds and slows the sun to follow the tropic lines?
What speeds and slows the sun?
Yeah.
We don't know. We don't know. We don't have a body like NASA doing this research, but he's absolutely right. It does. It does. And that's where Kepler's laws are extremely important. Because Kepler said the sun moves and rotates he said the Earth moves at a different speed based on its ecliptic orbit. It's not true. If you apply that principle to the flat Earth, the sun is moving at a different rate. Okay, so it has to move quicker in the winter in our summer solstice to cover more distance than it does in the summer solstice, where the Tropic of Cancer has a smaller radius. You're absolutely right. It's a great question. I don't have the answer to that, mate. I don't, because I can say to you, God put that in place, but I'm not going to go down that path. I don't know enough about it. It might be in zetetic astronomy, which I haven't read. about with the speed of the sun. But we do know that Kepler covered off brilliantly. That's part of Kepler's work, which I love. And he showed that there was a difference, but he attributed it to the ecliptic orbit of the Earth, not to the speed of the sun, which was incorrect. But that's a fantastic question. Thank you for that.
So we don't know.
We don't know. No, we don't know. We don't know.
Indy Tiger for $10 says Polaris is the North Pole star. 6,000 years ago, it was Alpha Draconis because the Earth moves. The sun moving between the tropics demonstrates the Earth's tilt.
Incorrect. Their claims, where are the references? There's no tilt. I can shut the tilt. Okay, give me a chance now. Time to shut down the tilt. You ready, Michael? This will answer this question. It's a great segue. All right. So, do you know what the celestial sphere is?
Yes.
Great. So it tells us where the constellations are. Now, for all of you Australians that are listening, what is on our Australian flag?
It's the Southern Cross, yeah.
Thank you very much, Michael. That's known as the constellation crux. And why is it on our flag? Because it's seen every single day of the year from Sydney. I can see it every single night on a clear night, the same spot, and your celestial sphere says it's 60, it's a declination of 62 degrees south. Perfect, because it is. It never changes. Same position all the time. Now, let me explain this to you. If that's the case, I need to turn this down a little bit. If that's the case, this is the sun. This is the sun. This is the Earth. Let's agree that's nighttime, right? Michael? That's nighttime?
Yes, yeah.
Thank you. Sydney is about here, 33 degrees south.
Yep.
Okay? Crux is down here at 62. It's further down.
Yeah.
Now, great. Your heliocentric model. Your stars are fixed in place, right?
Yep.
Millions of light years away, something like 400,000 light years away. Now, 6 months later, the Earth is here.
Yep.
And I can still see Crux in the same position, but Crux is back here. Still the same declination, same position. I'm now looking 180 degrees the opposite side of the solar system.
No, but the
Laugh
bottom.
all you like. Laugh all you like. It's impossible. It's impossible. Laugh all you like. There's
the bottom of that apple is still pointing there. So Crux isn't.
Rubbish.
Crux isn't on the table. Crux is very, very far away.
No, it's 12 degrees. It's 12 degrees ascension.
Yeah.
It's 12, I know the exact position of Crux. I can take a photo for you every single night. Doesn't change. And no, I can't now, during 6 months later, look towards the sun, back towards the night sky. No, it doesn't work that way, Michael. I'm sorry. It doesn't work that way. So the tilt, let's just go back to the tilt. If that's your tilt, 6 months later, if you're down here, even though you can't see Crux, wouldn't Crux declination now change from Sydney? Because Sydney's now 15 degrees in a different position.
No,
Are you with me?
the sun, the Earth doesn't wobble. It's not.
No, it doesn't wobble. It doesn't wobble. It doesn't wobble. But right here, yeah, right here, there's the sun. Sydney's doing this, right? So Sydney is pointing 30 degrees down this way, right? Now let's go here. Let's go to the other side and turn Sydney this way, right? So Sydney should now be 15 degrees higher up. Yes or no?
What?
6 months later, yes or no? Very simple.
Sydney should be.
Yes or no?
No.
Should the distance? Should the? Why? Why? There's Sydney there. There's Sydney there. Right there, right there.
Yeah.
Right.
Okay.
Now what happens? 6 months later.
It's in the same.
Face the other way,
it's
right?
the same. Yeah.
How's it the same? And why is Crux still visible 365 days of the year?
Now,
and why is Crux still at the same declination, 62 degrees?
It's
not.
But you see it 12 hours different. So 12. So it's a.
So I'm sorry, but where's daylight now? Where's nighttime? Yeah. Nighttime is over here.
Yeah.
Michael, you can shake your head, but stars are seen at night.
Tony, I think it's that you're just not quite thinking in 3 dimensions, right?
Oh, no, don't use that argument. That's pathetic. I hear that all the time. 3 dimensions. These are 3-dimensional objects. 3-dimensional objects. The ascension, the position of Crux does not change. All your viewers can research that. It's online. It's right there. On your own celestial sphere. Does not change.
It's not a problem.
Right, it is a problem because you're now facing nighttime, which is 180 degrees in the opposite direction 6 months later. opposite side of the sun. You're now being displaced 186,000 miles, facing the opposite direction at night. How is crutch still possible on our flag? It's on our flag. How is it possible to be viewed from Sydney every single night of the week? Michael, I'm not trying to be difficult. Apply some logic. Forget science. Apply some logic.
Yeah. So all right. So here's.
So that kills your tilt. That kills your rotation.
No.
You can concede anytime you like.
It's cinnamon control.
You're starting to sweat. I can see beads of sweat, Michael.
No.
Is that the scotch?
It's the same thing. Oh, I didn't have much, and I'm not feeling it yet.
Michael,
I don't need much.
Please don't resort to this dismissiveness. It's beneath you. I hear it all the time from spheroids. They become dismissive. You're not thinking three-dimensional, blah, blah, blah. Denialism is not an argument. Present a fact. It shows me how. Okay, well, why don't we just do this? You want me to turn me into a ballerina? Stand up. Look towards your wall. Now turn around and look towards the other side.
You just said denialism isn't an argument. I had sent you several peer-reviewed research papers about the rotation, measurements of the rotation of the Earth, and all you did was deny.
I don't care. I've written scientific papers. I don't care what people say. I'm not a sheep. I'm not a follower. I'm a free thinker. Universities teach you that.
But that's just denialism. So.
No, it's not. It's doing your own research. It's thinking for yourself. It's challenging the status quo. Come on, Michael. It's challenging the beliefs. Gravity is the biggest load of bullshit, and that's why my thumbnail. Right. That's my thumbnail. I use that thumbnail on purpose. Scientists still don't even know what the value of it is. After all this time, Cavendish experiment is a joke. There's been 350 attempts over 200 years. Not one of them has had the same answer. That's called a replication, a reproducibility error, a reproducibility crisis.
Slow down a little bit. You're going from topic to topic. We just can't do that. We can't do that.
Don't use the argument of peer review. I don't care.
That's denialism.
No, it's not. But it's not at all. It's do the right research. I can destroy gravity with Archimedes' principle.
All right.
Archimedes' principle was around 1900 years before Newton, Michael.
You're just going. You gotta.
But you're talking about science and peer review. You asked me a question. I'm answering it. You're talking about science and peer review. Archimedes destroys gravity. And it's been around for 1900 years before Newton. I can take gravity out of your buoyancy and show you it's irrelevant.
All right, let's wait.
I think that's a debate for next time.
Yes. All right. Truth Nerds says, and this is to address something you brought up before. Neil deGrasse Tyson said you couldn't see the curve from 128,000 feet, and I do not agree with Neil there. Not from orbit. And it's an appeal to authority.
No. It's not an appeal to authority. It's telling you what your thought leader says.
And he's not my thought leader.
Well, then where do you get your source from? Where do you get your information from? Who do you research to get? If your own thought leader is saying you can't see curvature,
not from Neil.
Okay, so that's a really good question. Right. That's a really good. We can start throwing these logical fallacies around because they're a cop out. But let me just say something. If you want to talk about the curvature, where is it?
I gave you the measurements already.
No, but you showed me a photo of blue marble where NASA employees have actually said it's a composite. You know what composites are? They're thousands of little photos.
Nobody says that picture from 1972 is a composite. Nobody says that.
I think you need to do your research, Michael.
I've absolutely done it.
Let me tell you something. For that photo to be taken,
Robert Simmons said specifically that the one photo that he made is a composite. Yeah. He was not talking about the one from 1972, which was done before Photoshop existed. That was taken on a film camera, developed in a darkroom, and is in a museum Hold on, my sentence.
Yeah, sure.
My sentence wasn't done. That you can go look at with your own eyes and go look at it.
Okay, 1 second. Hold that thought, okay?
Okay.
Hold that thought. I want you and your viewers to zoom in on that photo that you sent me. Okay? You can bring it up if you like. Can you bring it up?
Sure.
I want you to bring it up because I want to point something out to you. Just so you don't think I'm lying to you. You know, we've been going for 2 hours.
I know.
I just want to show you something to prove you're absolutely right.
All right,
okay?
there you go.
Now, okay. So I want to look for it because you really have to zoom in really closely. This is from that photo. I'm just trying to find the positions for you where. Yeah, you'd have to zoom in. Okay, this is what you find. This is what graphic designers, if I come back, Michael, get rid of that. This is what graphic designers have found. Have a look at this.
Wait, no, this picture is the one I'm talking about. This is the
right.
picture that I am presenting as a photograph of the Earth.
Earth. And this is what happens when you zoom in on a certain position. I can't find, I think it's somewhere off to the left. You find copy and paste clouds.
Yeah, but nobody's looking at that one. They're looking at this one, the one that I'm showing you. So the one that I'm showing you doesn't have, you're looking at a different one.
No, I'm not looking at a different one. I want to try to find it. This is the same one I'm looking at.
You're looking at the one. You're looking at the one from Robert Simmons. This one is from 1972.
Just look at the cloud. The cloud is exactly the same in the middle.
Okay.
Exactly the same.
All right. And where should I zoom in? This is the high res version.
Yeah. See, I can show you. There's a really good clip of a graphic designer doing this. I'm going to add that to the links to send you. Okay. He shows you that, then he zooms in on a position and he shows you the copy and paste cloud.
From the 1972.
Yeah.
Okay.
Because let me tell you something. You need to go well outside lower orbit to get this photo. And you talk to anyone.
And that's where this was taken. This was outside low orbit.
Well, if you believe the Apollo program actually existed, if you believe, right? That's another discussion. This is not outside low orbit. Even your Obama went on file and so went on record and said, we've never left lower Earth orbit. Except for the Apollo program. So was this taken during the Apollo program?
1972 was the final
and that's
Apollo
the claim
mission.
you're making? That's the claim.
Yeah.
So when I send you the evidence that this is a copy and paste job, will you share it with your viewers?
Sure.
Okay, great.
The 1972 one, not the 2000 something one.
It's called Blue Marble.
Well, there's two called the Blue Marble.
The new one they call Blue Marble as well, yeah. But this is the original Blue Marble.
So, all right.
Okay, so links to that. Okay.
All right. I need to read a couple more here. So
but
you keep getting off track
we
here.
just have to make sure this. I've kind of gone through some of my stuff. I've spoken about crux and how that destroys the tilt and rotation. I've spoken about how the rotation is destroyed by the centripetal force. But there's one more thing about the sphere geometry, how that fails. I'd like to get to that eventually.
All right. Well, let me.
Unless you've conceded.
No.
I'm happy to stop.
That's
no, not yet. Okay, you will. Keep going, Michael. What's the question?
All right, Hugh Jars, who's from Australia. Do you know Hugh?
I don't care where he's from.
Well, I mean, he's from Australia, so you must know him.
Don't care. I don't care if he's from Mars looking in.
Do you ever get those people? Do you ever get those people that are like, "Oh, you're from Sydney. Do you know this person?"
Yeah, that's right. Yeah.
You know
especially when you have
especially
when you have an Arabic heritage like me. Anyone with an Arabic name, I'm supposed to know.
All right. So Hugh is saying, how can there be a South Celestial Pole on the flat Earth?
How can there be a South Celestial Pole?
How can that even happen?
That is a link I need to send you because it's explained brilliantly. It's all about perspective and how perspective works. It's not as simple as here's the central pole and here's the central pole. No. Do you know what crepuscular rays are? Sun's crepuscular rays.
It doesn't have anything to do with.
It does. Stop.
Okay.
I'm answering right. Do you know what anti-crepuscular rays are? Michael? Right.
You
have the sun here, shines out crepuscular rays. 6,000 miles later, there's anti-crepuscular rays on the opposite side of the horizon. Opposite horizon, those converge. It's kind of how the polar central points work. Polaris, Sigma, Octantis. That's all I can say without getting into a lot of detail.
Yeah,
you need to listen to this clip and you need to watch it. And I'm happy to send you that clip. That will explain how it works.
Is that the one from Eric Dubé?
No, don't give a shit about him.
Okay.
I don't care what he says.
Well, if it's a clip, it's a video. I was thinking.
No. It's a clip. It's a clip of a scientific professor talking about how crepuscular, anti-crepuscular rays, and how Sigma, Octantis, and how Polaris work on our perspective.
Okay. Oh, hey, this one's topical. The Sun Express says Star Trails.
Wait 1 second. Wait 1 second. Sorry. I need to just write this down. I don't want to miss any of this.
Okay.
because if I can't provide backup, then anything I say is just opinion, right?
Yeah.
Go ahead. What's the question?
The Sun Express says star trails and their counterclockwise versus clockwise rotation example is easily solved with the ceiling fan. So a ceiling fan would be if there were a dome or firmament, look up and have that be the ceiling fan, and you could put glow in the dark stickers on it, right? And then lay down or look underneath it, right? And then put one near the middle so that can be like Polaris, and then put some near the outside so they can be like Sigma Octantis.
Outside of what? The fans?
The ceiling fan, yeah. And then turn it on, turn the light off, and see where the glow in the dark stickers are.
That analogy is ridiculous.
Well, how's
Absolutely
that not
ridiculous?
How's that
because,
not the dome?
Because I need to get over the other side of the fan and look down on it because it's the Earth you're saying is rotating. Let me tell you how your fan works, right? Here's how your fan works. Are you with me?
Okay.
Are you with me?
Yes.
Okay. So the fan is supposed to be Earth. You're spinning, right?
No, for flat Earth, the ground. This is the flat Earth hypothesis. The flat Earth would be the floor of the room that you're in, and the ceiling fan would be the stars in the firmament.
I can't believe we're still talking about this. But let me try again.
Okay.
I don't know how you're going to be able to see this, right? Yeah, I've drawn a bunch of stars on the page.
Okay.
This is the Earth, right? And there's more stars on this here, right? So I'm holding them above, right? Stars below, stars above. This is the Earth. No. I'm spinning this way. Just hear me out. I'm spinning this way, right?
I'm not asking about the globe. I'm asking about flat Earth.
What about the flat Earth?
How does it work on flat Earth?
I just told you I'll send you a link to explain that. No. It's not something that I can verbalize.
But that's what. But his point was a ceiling fan. The floor of the room that you're in. The floor of the room that you're in is the floor of the room you're in is the floor of the flat Earth, right? That's the idea. And then the ceiling fan then has stars on it. So put a bunch of glow in the dark stickers on it.
Let's say the ceiling fan spinning this way.
And then lay down on the floor and look up at the ceiling fan, and that then would simulate the star trails if the Earth were flat.
Correct.
Okay.
Right, but that doesn't explain the south and the north. It's a lot more complex than that. Okay, because if that's Polaris and it's got all the northern stars spinning, as I said before, when you move away, those stars disappear, and the new ones come into view, right?
How does that happen?
That's what happens.
How's the geometry work? All right, we need the formula for that. Okay, we've got to move on.
I gave it to you. Distance times tan times the angle. Polaris is there. It then stops, and all the surrounding stars are no longer visible. And then this is what happens. You're now at the equator saying to move south. What happens? Sigma Octantis and all those stars start to come into view. Very simple. Very simple. Nothing complex about it.
Okay.
But I said I need to send you a really good link. Explains that perfectly.
I would love to see that. All right. Truth Nerds says again, Tony, regarding star rotation, Mark Twain, it's going to be a little dig here, said it's better to keep your mouth shut and appear to be stupid than open it and remove all doubt. Truth Nerds, that's mean.
There's someone has come up with a newer version than that since Mark Twain. Isn't it something like you're better off keeping your mouth shut, letting people think you're stupid, than opening it and proving them right? It's just a new version.
It's a different version.
There's new velocity. There's new BS since Mark Twain.
Indie Tiger.
Thank you for taking the time. I don't understand, Michael. Do your viewers think they're hurting my feelings? Why do they waste their time? Have they got nothing better to do? Ask a proper question. Why doesn't one of your viewers say, Tony, interesting point, send me a reference on this, send me a reference on that? Why don't you be educated? Why don't you come up with educated responses
here's
rather than moronic bullshit like that?
From Indie Tiger that says, what other height would you use for calculating the horizon? This is for the distance to the horizon, I think. You can't...
Any height. Any height you like.
You can't... Hold on, I'll finish. You can't see through your belly button or your hands or your nose. Of course, calculations to the horizon is eye level.
And that's because the horizon is always at eye level. What's the point? That's the point. The support for my argument, which is it's always at eye level, regardless of what your photograph shows, It's always at eye level because your own formulas tell you it's at eye level because that's one of the variables. I don't understand how many ways I can say that. It's a variable in your own formula.
Yeah, but you can just
Michael,
measure it.
Smile all you want. Smile all you want. It's like it's unfathomable that you're still arguing with your own formula. You brought up your own formula, and I showed you feet is where your high levels are.
But that formula doesn't say the horizon is at eye level. You just say the horizon is at eye level.
The ones I have do. You chose one that conveniently doesn't say it, but the feet actually mean feet, which is the distance to your eye level. Okay, why don't we just do it to your mouth? Let's measure the distance to your mouth.
Yeah, but those formulas don't declare that the horizon is at eye level. That's just what you've declared.
Yes, they do. Oh, yes, they do. Would you like me to find the ones that I here and just show you them?
Where the formula declares that the horizon rises to eye level?
Just give me a minute. Read a few more comments. Okay. See if anyone has anything of substance to say. Let me find this for you, okay?
Humphrey
Give me a minute.
Sure. All right. Humphrey Pushcart says his star rotation misunderstanding is answered with a visit to any planetarium.
Think for yourself.
And then I'll leave the rest off there, Humphrey. And Aaron Armstrong is asking if you have a link to your thesis.
No. Tell Aaron that if she does research, she'll find far smarter people than me who have done the work.
No,
let me say something.
From when you were at university, I think.
Yeah. My thesis is not published.
Okay.
It's a university thesis. Okay. But listen, I'm sorry, I misunderstood the question. But guys, none of this is my opinion. I'm not some brilliant person. Please don't think any of this matters. I'm just a vocal piece for what's out there. I'm just telling you the research that exists. If you ask questions you've never asked before, then you'll find answers. But we don't, do we? We never question the Earth's shape. We go through our entire life and never question it. You did, but look where you are, Michael. Look where you are. You've made it an issue. You've made it a subject in your life. How many people go through their life trying to pay bills, trying to feed their family, trying to get work? They don't care about this. And you ask them, the Earth is a sphere, and that's fine. I'm not here to change the world. I'm just telling you, question it. I used to laugh at flat earthers. I used to ridicule them. Then I was challenged to find a curve beyond the horizon, and I couldn't. I'm not stupid. I'll tell you now, I couldn't do it. And when you have a sun, which we touched on before, that can be brought back up into the sky with magnification, that's not a sphere rotating. And I'm going to send you that link just so you can see with a filter, with everything. Magnification pushes out your level of perspective and it brings the sun back into view.
Great. Everyone
needs to. I don't care what you believe. I'm not here, Michael. We're not going to change minds. A mind can only be changed if they want to. They've got to do their own research. I'm not here to change anyone's mind. I'm just here to have a discussion with a guy I think is an absolute gentleman, and that's the end of it.
Yeah.
I want to show people, if nothing else, that a flat earther, a sphere earther can have a discussion, agree to disagree, walk away and come back and do it again another day on another topic. It doesn't have to be hostile. It doesn't have to be as ridiculous as it gets. That's all. If we can achieve that today, that's great. But let me find those formulas.
Okay.
See if there's anyone else that's got a decent question.
Ooh, this is a good one. Robeeb, I'm getting a little feedback now from the audio. I don't know if you changed something or not, but Robeeb says, you know more about the sphere Earth than sphere Earthers do, in the same way that sovereign citizens know more about law than lawyers do. I think that's a good one for you.
Oh, that's a really good one. And let me tell you something. Us lawyers have made a fortune out of using jargon for absolute simple terms. If you spent time researching the law, you'd be able to defend yourself, defend others, argue your case in family law. Don't buy into the BS. Don't buy into BS.
What do you think about sovereign citizens?
What's that got to do with anything?
I don't know.
I have an opinion on it.
Because there's a couple channels that used to do flat Earth content that now cover sovereign citizens. So a lot of the audience is the same.
I don't have a view on it. My opinion means I don't have an opinion on it. Okay. So let me go back to this. Okay. So there's I just googled it. Some WikiHow came up. Okay. How to calculate the distance to the horizon. Right. There's just a simple page. Okay. So it's got Let's go here. Here's method 1. Calculating using geometry. The length between the ground and your eyes. You can just read that clearly, right? Now,
I can't really read it.
So measure the height of your eye. That's step 1. Then move on to method 2. What does that say, Michael? Can you read it out?
I can't read it. It's too small.
Can you?
Let me look on here. Hold on. It's out of focus too. When we get that close, it goes out of focus.
It says local height of the observer. Then we have height of the eye.
Okay.
Version 3. It says height of the eye, 6 foot, distance to the horizon in miles, square root of 1.5 times the height of the eye in feet, or square root of 13 times the height of the eye in meters.
Okay.
Why? Why is the distance to the horizon accurate with these formulas?
Because
if it's not height of the eye.
Because it's the trigonometry of it.
Correct. So now if that height of the eye goes to the top of a lighthouse, you still get the accurate answer. Because it's the height of the eye. It's not the height of the eye back on the seashore.
Yeah.
It's the height of the eye where you are, because it's always at eye level. I don't know how many different ways
but
I
it
can
doesn't
say
that in there that the eye is.
Yes, it does. Yes, it does. I'm reading.
It doesn't say that the horizon is always at eye level.
But how can it not be if that's in the formula? How can you not infer that? Okay, here we go. Measure 3. Height of the eye equals 6 foot. Okay, in this problem, the distance to the horizon is square root of 1.5 times the height of the eye, which is 6 foot, equals 3 miles. Do we disagree or agree that the distance to the horizon is 3 miles? I think we agree on that, right?
If you're at a certain height, yes.
No, you're at sea level. He's just told you that the eye level is 6 foot. So you're at seashore, so we're at 3 miles. I'm showing you the science behind it using what sphere Earth is used.
But that doesn't say the horizon is at eye level.
Okay, I think we need to move on.
Yes.
Next question.
All right.
I'm not going to labor the point. It says eye level because it's in the formula and it gives an accurate reading. Take that eye level to the top of a lighthouse, you still get an accurate reading.
Okay.
So, okay, anyway, continue.
Chris Hoffman says, MC Toon, draw the globe in reference to Polaris. I'll do that. I'll put
the other point,
up.
while we're talking about that, while you're shifting around, here's my little sphere Earth, and here's my tilt. Can I ask you something, Michael? Can I ask you something? Okay. Do parallel lines ever meet?
No.
Right. Is Polaris in the same position every single night of the week? Every single night of the night? Every single night is in the same position? Yes. Correct?
With very, very small movement, yes. It's it moves about half a degree every 150 years.
Okay, great. So
leaving that out, then yes, yeah.
Okay, let's do this. Here's the sun again. There's our tilt. There's our Earth's tilt. Okay. Now here's Polaris, right? Polaris is directly above the Arctic Circle, right? Yep. Now I move this Earth. I displace this Earth by 186 million miles.
Yeah.
You with me? And on my tilt, see where my tilt is? My tilt is over there. And it's over there. Do parallel lines meet? Am I still looking at the same place?
Right here, I got this here. Here's the Earth. And there, these arrows point towards Polaris, which is very, very far away.
Right. So
I can't put on the paper, it's too far away.
Okay, but let me explain. You've got one of the arrows coming off the equator, but you can't see Polaris from the equator.
Well, yeah, it's right at the edge there, right? Yeah. So
you can't see Polaris from the equator.
Well, you can a little bit south because of refraction, but
okay.
Or from a mountaintop or something. So here's let's tip it. So there we go. Here is
let's tip it. But let's look at that parallel line and let's make that side of a triangle, right?
Yep.
So now we move
to the other side of the sun.
Yeah, so we've displaced it by 187 million miles, right?
Yes, and so we should see some.
How can that still look directly above St. Polaris?
There's parallax then you'd expect to see, right?
But we've just said parallel lines don't meet.
Yeah, so parallax, if absolutely parallel lines don't meet.
I'll say like this.
So the angle here and the angle here should be slightly different. And that's called parallax.
187 million miles is not going to make a difference to our perspective.
Well,
Polaris is directly ahead. Doesn't change.
depending on how far away Polaris is, right? If Polaris is close, then this type
It
of
makes no
distance makes
difference.
a difference.
Makes
Oh,
no difference. If it's directly above the Arctic Circle, and you move 187 million miles, it's not going to be directly above it.
But what if
you
it's
have to look backwards a little bit? Then I agree with you. But
hold
no.
on. What if the distance from here to here, millions of miles? What if the distance from here to Polaris is 100,000 times more than this distance here? How much shift should you see?
Then we would still see. Then we would see a slight change in the angle, right?
And that's called parallax, and it's been measured.
But it's not. But it doesn't happen over a period of 6 months.
It does.
It's always in the same. No, it's always in the same position above the Arctic Circle. The center of the Arctic Circle. We call it zero on the flat Earth.
But it's not zero. It's about half a degree off the center. Polaris
Okay,
is.
but does that half a degree change when it goes to 6 months later? No.
It's much less than half a degree change, but there is parallax in Polaris's position.
But you're talking like 187 miles is nothing. 107 million miles is nothing.
No, I'm saying
it
is enough that we can measure parallax.
Okay. Thank you for your response.
So, all right. There. So Chris Hoffman wanted me to draw. So this is the prediction of the globe Earth, right? That Polaris would be at 45 degrees where I'm at.
That's not a very accurate prediction. That's not what it would look like anyway. Let me tell you what it would look like on a sphere Earth.
Okay. Here we go. Philip Kidd says Polaris's parallax is 7.54 plus or minus 0.11 milliarc seconds per year. So there is a measured parallax.
Thank you. Thank you.
People are impressed with your energy level.
I want them to be. I want them to be impressed with the fact that we're having an amicable debate.
Yes.
That's all. Just be impressed with that, and I'm happy. Okay. Okay. So this is more about how it would look, right? This is. Are you having a go at that?
Yeah, I got that. All right, go.
Is that the one where you can't remove the stickers on that one? Can
There's
you?
no stickers. That's
what I mean. Because in the old days we used to just remove the stickers and put them back in place.
What happens when you remove the stickers? You never get it back on.
That's right.
Right.
Okay, look. Let me say this is what it actually looks like on your sphere Earth.
Yeah, but hang
on a second.
How far above the Earth do you think that the globe says that Polaris is?
Well, I've only got enough room on my page, mate. It's not a fucking two-scale.
Much farther. Much farther.
It's not a two-scale drawing, my friend. This is what it would actually look like. Are you with me?
Yeah.
Michael, you can play with that in a minute. I'm going to wrap up because I've got to go. I can't stay here all day. Look, Polaris directly above this. Oh, you're not interested. All right, let's call it.
I'm listening.
Let's call it.
I tried.
Let's call it.
Okay, I'll stop.
You're not interested. Listen, have another drink.
I'm out.
But this is what it actually looks like.
Good.
Okay, just for your viewers.
I'll have some Toon Shine.
Does that shit still exist?
Toon Shine?
That's water. That's water.
That's not water. Hold on, I'll have a little tab too.
Yeah. Okay. Tab still exists in America? Holy shit. Okay, keep going. Last point. That's what it looks like. There's the equator. Some people may see Polaris, which is right in that across their horizon. That's how it would work on a globe Earth, not the way you showed. Okay, directly above the Arctic Circle, and then there you live here at 45 degrees. Looks low in the sky, etc. All right. How about we call it? Let you get drinking. Let your viewers pour out their vitriol about the debate, and maybe we can tee up a time to discuss gravity in the near future.
Okay.
How's that, Michael?
That would be good.
So you're a flat earther now or not?
No.
Okay,
It's been fun though. I definitely appreciate it.
I told you it would be. If more people showed some respect, then these debates will be interesting. When people get all worked up and start talking shit, it's just boring and it's childish. It makes no difference to me. People think of me.
I agree.
I don't care about your feelings. I don't care how you feel. There's your truth, there's my truth, and the facts that belong to one person. Who you decide is up to them. Let me destroy gravity next time, yeah? But only if your shirts. I'll destroy gravity. No doubt about it. No doubt about it. And if you can refute Archimedes, density columns, periodic table, everything, and observation, then I'll be really interested to see, because far smarter people have tried and buckled. Okay, but that'll be a good discussion, Michael. It'll be good fun again. Yeah, it'll be good fun, and I'm happy to do it. In the near future, if people buy your T-shirts,
they have to buy my T-shirts.
Yeah, they have to buy your T-shirts. If people don't buy your shit and contribute, there's no point being here. What's the point?
Well, I'll
And listen, if anyone wants to contact me, I'm happy for you to give them my messenger details. And remember, guys, you have to request to message me. So if you message me bullshit and crap, I just reject it. So if you want to ask me serious questions, go ahead. One of the things I'm doing now, this is a shameless plug. I'm trying to reduce the amount of law that I'm doing, and I'm getting more into personal mentoring and coaches of senior management, middle management. So if people want to spend some time learning how to improve their careers and how to get ahead in corporate, I've worked all over the world in CEO positions before I became a lawyer. I'm happy to train people, and that's a selfless plug. If you want to message me and talk shit, you're just going to get a rejection on the message. But Michael, happy for you to give my details. I think it's easily found anyway, because I've given everyone my full name and my real name. Yeah, I'm happy to hear from people for both sides.
So I'll ask people. Don't be rude. Everybody on both sides of this debate tend to go that direction. Let's not.
Yeah, they can be rude. All I can say is EAD to all those people. I'm not going to say what that means, but you can eat a D. You know what? You can eat a D if you want to be rude. I don't care about your feelings. Don't waste my time. I don't want to open messages on Messenger of absolute morons talking shit, because I'm going to make you meet me in a park and you're going to wait for 2 hours in London while I'm in Sydney, like that absolute dickhead. Sorry about the language. And I'm happy to play you like a little puppet, mate. I'll play you like a flute if you want to carry on like that. All right. Michael, it was an absolute pleasure. Thank you very much, mate. We are still mates.
Yes.
Before and after. Anything you need, let me know.
And if I'm in Sydney, I'll come find you.
You have to visit Sydney when this ridiculousness ends.
Yes.
With COVID.
I'd love to.
And you'll stay with me. Your family can come and stay with me, and I'll do your head in with flat Earth the whole time you're here. You've been dreaming about it. But listen, thank you very much for your time, and viewers, please, whatever references you want, let Michael know. Michael, please send me a list. I'm happy to send you everything, clips, references that I've discussed for your viewers to have a look at. Okay. All right, guys, buy his shit, buy the shirts. Contribute, otherwise he'll stop doing it. He doesn't need to hear from arseholes like me. Help him make some money.
You're much better than some others. I'll tell you that for sure.
I don't care about others. I think you can do this respectfully. I can be as scathing and ruthless and a rude prick if people are the same to me. But I'm not. You're not that way. So you started to lose it a little bit then. You started a little bit, but you pulled it back.
I was at a loss for words on how to explain something. So,
all right, good. All right, good. So I made you think a little bit, which is good.
Yeah. All right. Well, thank you. I'll read a couple things here before I go. But Tony, thanks a lot. We'll catch you some other time. It's my pleasure.
Hope you had a good time. I did. Thank you very much.
All right. Bye.
Cheers. Bye-bye.
All right. Well, people, we've got this here. I'll read the rest of these super chats here. And this is perfect from Rubik Cube Earth. Says, so Polaris is just a few hundred miles up. That his last drawing was totally that. But yeah, the Polaris parallax is quite something. It's back to you, right? So thank you for that, Rubik's Cube Earth. K-Bear says, I told you that your video about the stupidest thing ever said would be a challenge for some of these people. You're right. If you didn't see it, I put a video out a couple days ago, the stupidest thing ever said by a human. And people are like, hey, the flat earthers are going to say, hold my beer. And I think that they're working at it. The thing that I think is the stupidest thing ever said by a human is Mark Steele, when he said that the Ark of the Covenant was 5G and it was a direct energy weapon. Basically thinking that the Raiders of the Lost Ark was a documentary. So Kang024 says, Tony, here's my response that you asked for. The sun does not change in angular size. I have filmed it. Correct. It doesn't change in angular size. It's always with sloppy. Now there are a couple times that they have it with the solar filter, but they get their exposure wrong. So you can still make that mistake. So sim and control question for him. At what distance will the 10-foot lamp post disappear below a perfectly flat road? That's a good one. I will send a couple to him. Where'd that go? A couple questions for you. TEH, there we go. Go the Dockers, says Daniel Callaghan. Who's the Dockers? What's the Dockers? Is this a sports team that is themed on Levi's pants? I'm confused. Anyway, NA for $6.66 says, who is this MC Tune? Hail Santa. Santa. Love Santa. Brad Dubay says, how high is Polaris from the North Pole? Basically, it's zenith. From the last drawing, it's just a little bit. Just a tiny little bit. Roby, oh my gosh, this is going back a couple years. This Justice for Harambe. Then 07. I don't know what 07 is, but yes. Or Harambe. A moment of silence for Harambe. Thank you. That was a moment of silence. Toby for €5 says, thanks for answering, but my question about the means of separating between psychotics and flat earthers was aimed at MC Toon. I don't care about this babbling mental dude. It's a good question. My first thing is I try to not have people on that I think are fake, right? So when people are like, I'm sensing Poe vibes, I've done what I thought was enough to shake out whether or not I think they're a Poe. I could be wrong, certainly could be wrong. So how do I but beyond that, from just a flat earther that's a legit flat earther to a maybe psychotic. I don't think Tony was a psychotic, not at all. I like him. I think he's animated, and I think he's wrong, and he struggles with geometry, and so I'm like, I don't know if you could have done physics, really, at least not advanced physics, but I don't think he's psychotic. I don't know. Maybe other people disagree with me, but I don't think so. So, Pen 15's out for Harambe. Yes. Go ahead, Quiddies. Get out your Pen 15 for Harambe. Humphrey Pushcart says, hourly the sun is measured to deliver about 430 quintillion joules of energy to Earth. What is the mass of the flat Earth sun? What is the method of energy production and fuel? Show the math. Dude. You're asking a lot. I'll send it to him. But we know the answer is going to be, I don't know. It's a good thing though, because you got to work backwards from that. We can be pretty certain about how much energy the Earth is getting from the sun. In fact, if the Earth is flat, it's more, because if the Earth were flat, the surface area of the Earth must be bigger. As it goes farther south, it has to get bigger, so that doesn't work. Kuras says, so this flat earther has numbers, but he clearly doesn't have the maths. Yeah, I think he doesn't quite get the geometry. He didn't do it, and he got he thinks, here's the problem. He wanted to put in the latitude into the equation, so he's like taking the tangent of the latitude, which doesn't work. MC Toon, as a bipolar person with a BA in psychology, I would ask that we not diagnose people as psychotic. Thank you. I agree. So take it up with Toby. So like I said, I don't think he is. Here's the deal, and we can all have our own differing opinions on this. I think that I have I'm pretty sure myself that I have run into some psychotic people in this flat earth thing, and I don't want to mention who they are, and I don't want to disparage them. And so it is, I mean, it's a good balance. It's a good question. There are some people that are definitely out there, and for me to go and do this and then profit off of it, is that wrong? If somebody was psychotic and I'm just putting them out there for that, could be a legitimate thing to ask me. Legitimate thing to be concerned about. I don't want to be the person that profits from that type of a disability. So, so there you go. Stevie B for 10 pounds says Tony's very passionate about his belief, but that does not make it right. Correct. And I think that we really saw, I lost it on the floor. When he took the angle to Polaris and he worked it backwards, right? He took the observed angle and then said, well, here's what we see. Therefore, the geometry works. It doesn't. Is it Russian vids? No, it's not Russian vids. I think I suspect Russian vids is just faking it. So, F up world, I don't think you're crazy either. I don't. We should meet up sometime, Joe Hill. We should. He lives in Minnesota here, so we should definitely. I think in September. What do you think? September, some weeknight, we'll get together in Minneapolis somewhere. So Cinnamon Control says, wow, we just discovered circumpolar constellations. Yeah, so he struggled with the geometry of that. And I was at a loss for words because I'm like, it's a basic thing that how can I explain to somebody that missed that geometry that's pretty obvious? How can I explain it to that person? I just kind of, I bailed, didn't I? I'm like, I can't explain it to you. I don't think that there is a way that I can explain it to him to make it sense. I could maybe like get a globe and like be in the same room as him and do it, but that's about it. That's about it. So I heard something. People are out there. Love this name, Mr. Sleepy. Hi, almost done. Yes. Just a second. And what? Oh, good idea. It's garbage day. Yes. All right. Got to bring the garbage out to the curb or we'll have an extra week of garbage. That sucks. I should have given him the litmus test. I don't like the litmus test a whole lot. Because it's always the same. Right? And they are a little bit of a trick question. If you ask people that aren't flat earthers, what's 5 divided by 0, and they're not into math, many of them will get it wrong. But of course, the irony is that a lot of flat earth, like Riley, for example, claims to be really good at math. So then he should get that right. So, all right. So Mr. Sleepy, middle name is King and first name is Sofa. Reverse all those for you if you want. It says, I'll go south as far as south goes. What's that from? Did he say that? Papa's Rex. I'm receiving instructions from my handler. So my wife went to a rodeo tonight. So there you can all look up where was a rodeo in the Minneapolis St. Paul area tonight. She was there. Put it, people, go ahead right now. Put it in there. Tell me where there was a rodeo tonight. Holy Small says the closest star to us is 268,770 times the distance to the sun. Scale's important when you're talking about cosmic items. Yes, and scale is always a problem with flat earthers, isn't it? Even a flat earther that studied physics, apparently. Rodeo. The joke potential is high. Yes, I did not. I did not go to the rodeo myself. I It's a little too country for me. I mean, you might, if you go to a rodeo, you might accidentally hear country music, and I just can't take that risk. Right? The Sun Express says the ceiling fan example, standing beneath it, looking up, the fan will turn clockwise. Following that rotation, looking down to ground, rotation is counterclockwise. He wouldn't, it was telling, he wouldn't acknowledge the apparent rotation of the ceiling and the apparent rotation of the floor. He only would talk that he was moving one direction. That is the problem. That's the problem. Has he gone? Yeah, he's not here anymore. So I don't have no rodeos. Nobody's saying rodeo stuff. Let's see. NANA says, we enjoy mocking the stupid. Hail Santa. For $6.66. I almost slipped up there. I mean, yeah, I tell people this entertainment for intelligent people. Bev, you know, Bev, try thinking Bev. He gets so mad. He's on Twitter all the time. And he's like, Tune doesn't even, he just calls it entertainment. I'm like, yeah, correct. He gets so mad at that. Oh, this is a good one, Matt Klein. If there's a house where all four sides face south and a bear walks up to the house, what color is the bear? What color is the bear? It is white because it's a polar bear. Absolutely. Somebody's talking about Brian Regan. Okay. Rubik's Cube Earth says, Tony, the reason why no one's asking for references and information because we've all heard this before. You've presented nothing new, and it's all been debunked. True. Rubik's Cube Earth. For that one, I will solve this for you quickly here. He got a little offended when I started doing this. He says he's got some client calls to work on, so he had to go. We started at 11 a.m. for him, so it's middle of the day. So I can't imagine. Oops, I missed that one. That's wrong. I can't imagine having like a life coach that was a flat earther. I'd be like, oh, there was a series of decisions that you made that I don't think I want to be getting coached from that. But I don't know. Maybe there's a market for flat earth life coaches. Could be. Let's see. All right, here we go. Moving on to this. My cousin taught me this particular sequence here. I don't know. I don't even know the name for it. He taught it to me. That's where I got it. I committed it to memory many moons ago. There it is. And now flip it to got lucky on that one. Got lucky in that one. And here, ooh. Look at that. That was quick. And we're done. There it is. All done. Thank you for that, Rubik's Cube Earth. Glitch says, why doesn't the sun get smaller as it moves towards the horizon and goes towards the vanishing point for a sunset as it is flat Earth? Yeah, if it were flat, it would have to do that, but it would not go to the horizon. It would have to disappear much above the horizon, and there's the geometry that he's not going to understand. It's just, it was not Candy Yoshi County Fair. Yeah, it just wasn't it. That's, man, like he's so certain that he gets that he thinks the geometry is right, but it's not. I would not go to rodeo on Lake Street in Minneapolis. Holy cow, why would a rodeo there? Is that, I don't know. Somebody just posted 2709 East Lake Street in Minneapolis. What is that? That's why did you post that, Tim Brown? missing that one. That's a business. What is that business? Is it the rodeo? It's Ethiopian cuisine and vegan. Oh, is this a restaurant somebody likes? Oh, wait a second. Is that Calhoun? No, it's not Calhoun Square. No, it's not even close. Well, I've been on there. I've been on that street. Okay. Oh, geez. Jumped. Chris Hoffman, Tony, not interested in your gaslighting or misunderstanding of how things work. You've done a bad job providing evidence, but you've lied a lot. Don't think there's a question, the difference between a lie, somebody saying a lie, and somebody saying something that's not true. If they don't know that it's a lie, then what is it? I mean, it's still a lie, but from their viewpoint, they're not intentionally lying. So there's like a distinction there. So somebody intentionally lying is telling a lie, and that person is a liar. But somebody that thinks they're telling the truth is what? Brainy Beaver says, don't forget the eye of the tiger. How high is the eye of the tiger? Does the eye of the tiger rise to eye level? Does the horizon rise to the eye of the tiger? Don't know. These are things we must explore for the next time. Truth Nerd says, Tony, I apologize for my mean comment from before. If we go by number of words, you easily won the debate. I will send that. I'm going to send that to him. There it is. King Cruz says, Tony might be an idiot, but I like him. There it is. Andreas Eld says, I just love his answer. Of course you get different heights of the sun. That's perspective. Oh, they never know what perspective is. It's just something getting smaller. That's all it is. And it's predictable and measurable, and it always works. Peter Collins says, thank you for all your hard work. Love it. Well, thank you also very much to you, Peter Collins. NA says, was that my Rubik's Cube? It is. It is NA's Rubik's Cube that I was going to send you. There's a sequence of things I need to do. And the next thing in the sequence is for me to go to the post office and get a post office box. I did it online. I went in. They said, you need to come back tomorrow, or we need to call you tomorrow. And all the stuff I did online, they're like, we don't know. You have to do it in person. So to do it in person, you have to have a second proof of your residency. So you need a other than your license, you need a utility bill will work, or your passport. So I went there and I didn't have either. So then I was going to go today and I didn't have my credit card. It was I gave it to my wife. So darn it. So anyway, it's coming. And I have a couple other things to send out. So once I get the PO box, the next step is to send that out. So I guess it's a pretty lame excuse. It's been a while. My wife gave me crap about it the other day. So there you go. Was it Wilmer? No. It said it's not Bemidji. Your address is not on your passport. You're right. But they take it. They'll take your passport. I think it establishes the state you live in. I think it does. Anyway, so nobody has the fare, the fare that I kind of gave it away by saying fare, didn't I? Which fare? Did you drive or did you travel? I don't. You're right, Facty. I don't need a PO box to send a package, but I want to put my return address on it. I'm not going to put my home address on it. So there it is. It's the Dakota County Fair. That's where it was. So Dakota County Fair. Does the PO box rise to eye level? That's interesting. On Palestinian passports under occupation, does it say Israel? Oh, that's funny. Okay. Yes. Why? Because they don't want to dox. Yeah. So I want to give. So and I think King Crew. A couple people have asked. They want to send me something, and I'm like, gotta get the. So, what's tomorrow? Tomorrow's Thursday. Can I do it? I might be able to go tomorrow to get the PO box. So there you go. Heat shield. The funny thing about utility bills, they don't require any identification to receive a utility bill in your name. It's a free piece of accepted ID with no checks. You are completely correct. I think it's a very strange thing that I think is more about historical. It was more important historically than it is now, because if somebody wanted to fake it, you could fake it. So Syph wants to send me Danish licorice. Is it real licorice, like black licorice? I'm not 75. I don't like, I like the red licorice. So is the rodeo at Effed Up World's home? No. But if you're interested, he is a fantastic woodsmith. He's made some really nice different wood creations. And his workshop burned down though. So I don't know. I hope it was rebuilt and you're doing stuff again. In the meantime, I know he's doing some contract work on, I think, pillars around houses, like new house construction, putting the wood pillars up is really good. So just send me weird stuff. So there you go. Can you get a PO box under the name MC Toon Flat Earth Buster? You could put whatever you want, as long as it's after that PO box and then the right number, whatever it will be. So, and Vadim is going to send me a Mallory. I don't, do I want a Mallory? I don't know if I want a Mallory. So there we go. Anyway, that's what I have. Thank you very much, everybody, for sticking around for this very fun and interesting and a little bit fast talking Tony. I like him. He's entertaining, if nothing else, right? That's what I think. So next week I already have booked Jim Foster from Facebook. And the week after, I just booked also Outfox. So there's a channel called Outfox. I'll grab the link and you can all go sub right now. Who hosted a debate with a flat earther, and the flat earther that they hosted it with is a part of the Outfox crew. So Outfox is not a flat earth debunking channel. It is a I don't know. They do different stuff. Let me find it here. Outfox. There it is. Outfox. So I will put this in chat, and so go sub to that channel if you want to, or go sub to the channel right now. How about that? So the guy, if you look at that, the most recent video was a debate. There's two of them. Yeah, there's two debates in a row that were with a flat earther, and I think that guy's in with the crew. Anyway, 2 weeks from yesterday, Jacob, I think his name's Jacob, will be on, and that one will probably be produced by Dick Dawson. We'll see. I gotta check that. Anyway, that's what I got. Thank you, everybody. Let me prep the outro. You can watch that, and we'll see you again next time. Bye.